Hey folks, I am actually without headphones today, which sucks. Because I have to have music on loudspeaker, right? Which means it might bleed a little bit into the microphone. So you let me know if it does that. Right now, we are trying to add a few nice things to the byte pattern. I'm calling it byte pattern right now, compiler. So the byte pattern is essentially this big string, right? And we want to be able to do a few things to it. So, for example, we want to be able. Hey, Leia, what's going? You want to say something? No. We want to be able to pass in not just specific numbers, right, of bytes, right, but also values like variables, but also expressions, right. And so far, this works fine, right? If you do byte and you put a function here, then this function will get called right at the right place, and we'll see that in a second. But we cannot use parentheses, right? The elixir right now is pretty dumb in that sense. So we want to make it a little smarter, so that if it opens up parentheses, right, every time it finds a new open parens, right, then we have to expect another close parens right there. So if you find two open, then we need to close at the second, right? Close, not the first one. Easy peasy, lemon squeezy. Just I need to get it done. But I think before we do that, I'll make sure that this thing actually compiles to the right ocaml. So I'll comment out this test first, and then we'll see how this example wages through the pipeline, right? Because we have some elixir tests here, right? The first batch. Then we have some parser tests. So given the same string, what AST? In this case, the AST is super dumb, right? But which AST is coming up? Just checking the. Hey, Miner for Miner, thanks for the Prime subscription. And then we have a lowering, right, of the AST into something that is much easier to use for code generation. And in fact, we have two different lowerings. One of them is for when we want to construct strings, right? So this is the one. Like if you write this much and you want to create this byte string, which means you have these variables, you have all these values available, and you just want to put them together very efficiently, right, into a string, then this is the set of operations we're going to do. And then, of course, we have the full construction tests, right? When you run the syntax, this is the generated code for creating that. And then we have the same pair of tests for the matching lower representation, right? And this is designed for extraction of things, right? So if you say, oh, I want a pattern match on this thing, I expect the number 2112, right, to be laid out across 1,234 bits. So you create an iterator over some data source, and then you expect an int with a dynamic number of bits, right? And the value that you expect out is 2112, and the number of bits is this one, right, from this data source. So more complex ones like this one are nicer to look at because you can see, like, for example, we match fin, that's fine. We bind, right, the source variable's fin, to whatever is on the first bit, right, on the string that we're going to match on, right? This is like extracting the head, really, the first bit. But then here, we do something really cool, which is we're going to bind the variable length, right, to 8 bytes. So if you look at that here, we're saying, okay, we're going to do just that. Like the expression is going to be an integer number of 8 bytes, and it's dynamic number of bytes, right? This could be a function call, this could be whatever. Now len is available, right? It's a value, it's a variable. So we can use it to say the payload size is going to be this much, right? And if you look at this here, when we want to bind a dynamic number of bytes to the variable payload, we're going to use the expression identifier to variable len. And when we look at the code that generates all the way at the bottom, this translates to this series of operations, right, over a byte string iterator. So you get the first bit and you save it here, right? You can see how when you say len, this just declares a variable, right? And then you can use that variable in here, which is really, really nice. Now we just want to make sure that these expressions that you can put in here, right, um, are actually going to be function calls. The main reason for that is that I want to be able to say, like, okay, if we need to compute the payload, right, using some function, right, like some more complex function, right, that needs input from the string at first, right, we want to be able to do that and say we're going to parameter on the length, and we're just going to say the number of bytes is going to be a function call, let's say foo, right, that takes the length as an input. And then you can do your complicated math outside of this string, right? You can even test that math separately, which is nice. But this works just the same. Yeah, so that's a little bit of what we've been up to on Riot World. Did I get a notification here as well? In our, yeah, we did. Cool. So that's what we're gonna do. I may not look at chat for a little bit while I crunch through this. What's up? You okay? Oh, I'm not using any testing library at all. Let me show you my little test function. I love it. It is great. But I have become that person that's like, I don't need a testing framework. So test is defined at the beginning of each one of these suites, right? And I just pass in, like I build it specifically for this, right? I have printers, so I can do comparison of these data structures, right, on the printing level. And the reason for that is that when we start to embed the ocaml parse tree values, right, comparison with just equals doesn't work anymore, right, because these values are much more complex. Um, so I do that comparison, and then if it's okay, then I just print out this is okay, right? And if it's not okay, then I can do something with that. In this case, printing them. So we have a small error there, and that doesn't look very nice, right? But let's say I run this thing, and yeah, this is an example I want to give you. So this says that this test over here, right? And the name of the test right now is the input, which is pretty bad, but and it should be the last one, yeah, because we have the last passing test is match test on rush 3 bytes. So the last one is here. It says that expected this output, right, over there, but this is what it found. So I can just come here and just copy that code and be like, all right, that makes sense to me. So this is my poor man's, what do you say, snapshot testing, and that passed. So as you can see here, after we did the change and we do bytes and we want to call foo with the length, that is exactly what happens here, right? We end up calling the function foo with the length that we captured. So this is super simple. Oh, this expression is from the ppx lib.metaquote library, which allows you to, this is really an AST node, right? So this is a way for pre-processing OCaml code and turning it into the. Told you what? What do you mean, Butcop? It is useful if your tests produce OCaml code, right? Like in this case, when you call this function, we are actually returning an AST. So this library by pattern takes in a string as an input, right? and then it returns ocaml expressions like from the parse tree. However, I do think that this kind of testing, right? Like this is as little as you need, I think, to give someone a productive testing framework, right? Just a quick way of doing good equality checks, right? And pretty printing is terrible, but it kind of does the trick, right? Um, and then just tell me where it failed and what the right value would be, so I can just copy paste that. This is why when I was working on Caramel, almost all of the tests were cram tests. Because when you do cram tests, you say run this thing and give me the output, right? And then the Dune will tell you, hey, the output is not what you expected. Should we update it? So snapshot testing. It's really hard to come back from that. So, yeah, this does what we expect. That's good. The example I have here is one where I want to call compute bits, right? And this could be a very expensive operation, and I want to be able to call it with a unit, but I can't. So, this is the example I think we should be using. So we'll start up here, right? And we'll work our way down. So foo, we expect it to be this ocaml expression, right? And then it will fail to parse, and that's fine. So we can close this, and we can go back to the elixir. And the IU elixir here. Okay, cool. So when we do expression here, we will just count. So parents start at 0, or actually start at 1. Every time we find one, we bump it up. Every time we go down, we bump it down. So if we match on an open parents, right, then we just do the same thing here, but we're going to recurse with actually, I'm going to make parents mandatory. Because otherwise it's easy to forget when to add it. Had a couple bugs where I had this new optional argument and I run the thing because it compiles and it's like, oh, of course, I'm missing all of these places that I cannot tell where I'm missing, right? The parameter, because it is optional. So it helps to first make it mandatory, put it everywhere. So when we find a parents, we do parents plus 1. And then we want to do this only, right? Parent equals to 0. Yeah, I can do that. The hell is my microphone? Hello. Is that better? I think Ocaml got all of the syntax wrong. Not just a little bit, all of it is so wrong. Oh my god, it makes me so mad all the time. It is crazy. Yeah, like I don't mind let in, I don't mind match with, I don't mind, like that's fine. But strings are weird, very weird. I really like the. I'm gonna cry here. Um, Primarily, my pet peeve is around strings. I think right now dealing with strings that need to be tagged, extensible extension points of the syntax, it just looks weird, and it almost feels like it's made that way so that you don't extend the syntax. You know what I mean? It's like, okay, We're going to make it weird so people, when they have to use it, they realize, I'm doing something that looks weird, so probably it is weird and I shouldn't be doing it. I know people maybe don't necessarily think like that in that sense. Okay, this went down. We're going to replay. By the way, if anybody knows how to do loops on YouTube, more than welcome, because we're going to be listening to this on repeat. I woke up feeling like listening to Quake. It has some boring parts, but it's okay. Another thing is that we probably want to get rid of that, right? So when parents is over 0, then we'll just do the same thing we do here, but we'll bump the parents down, right? Oh, of course, we can't do that. So we'll do an if. Cool. What do you want from me? Oh, when we do expression, we'll start a parens at 0. Woo! That passed our test. Excellent, right? So now let's see. If we add something more complicated, right? Like we'll call foo, but we'll over parenthesize and we'll multiply by something and then divide by another expression. And I want this thing to just be matching. Excellent. Look at that. It's a beautiful, isn't it? Cool. So this should be ocaml, and then we parse that. I think I need to do expression ocaml like that. Passing. All right. So if that works there, we can grab these 2 tests, right? And we can move them down 1 level just to make sure that we have the right stuff there. I forget where I put them, but I'm going to put them, okay, maybe before rush. Empty assertions, go. Invalid size. What do you mean invalid size? Oh, this should be bytes. Okay, so that's a good point to also fix the error. The size, and then we have tokens here. We found an invalid size. And we probably want to do format, test, printf, right? And here is where these ugly multi-line strings come about, right? So I think Elixir has done this very, very well. Because in Elixir, if you do this, right, you can literally write your entire string at this padding level, right? And it will remove the padding for you. If you start it here, then it will start like it's the same as starting here, right? I believe. Or that's my memory of it. My recollection. We found an invalid size. And then we can put the size there. Valid sizes are bytes expression, bits expression, UTF-8, and a number. And number, for example. And then we have to escape our own string here. But it will be something like hello bytes, right? Hello bytes. compute size. Or length plus 8. Bits, byte size. This could be 124. We could have UTF here. And you can have 7. And now, why don't you like this? All right, we're missing a parenthesis. Are the volumes better there? Another pet peeve I've had, or I've been having more and more with the syntax, Dylan, is that some of the things I'm writing are starting to look very crowded, like unnecessarily crowded, right? Let me take you to the adapter code for HTTP1 for Nomad. Like, let's say here, right? The code for dealing with this. This will read the content length of a body. Now, Leia, no pode. And sure, there's a couple of debugs there that really should be trace calls, but you can ignore that, right? But the more I have, right, the harder it is to visually parse each one of the segments. Hey, Ryan. Leia says hi back. Go to bed, old man. So, yeah, you could argue, oh, well, you just make another function, right? And just call foo here and bar here, and why not, right? And then it becomes this super tiny, nice little dispatch thing. But that's not what I want. I have a lot of context around this thing. I need to maybe recurse over the same function. In this case, I don't. In the case above, I definitely do. So I would like to be able to just have breathing room. You know what I mean? It doesn't have to be so packed. That. More recently, working on the pattern matching compiler here, right? Some of the things that I have here, this is impossible to visually parse, right? And if I have to put a lot of work, right, into refactoring the code so that it's easy to read, right, then it must mean that the things that are natural in the language, right, are not easy to read. I know, but I've been complaining a lot. I'm trying to make things better slowly, but still. Thanks, though, Dylan. It reassures me that I'm not a crazy old person just yelling at clouds here. Damn, Ryan is the gift king here. So, line 242, we're missing here, right, the actual token string. And to do that, we can do lecture PV and put the tokens. So this could be as printf, like that. Not in love with that failure. Hey, Jekyll7. I'm just saying, you know, just for example, right? In Rust, the syntax itself leads to having that extra space, right? Because of the brace between the matches. Just as an example. Leia. Oh no, what are you doing? You okay? So when you do that, then you naturally have a little bit of breathing room, right? Between one and the next case, right? Like that. And sure, you can rely on a formatter to help you get this right and whatnot. But I don't want to change the default formatting. I think it should be okay. The default formatting should be the best formatting. Or, you know, for 98% of the cases. And if you are the 2% or less that work for Jane Street, then use Jane Street formatting, right? Ryan, yes, I've made a pattern matching compiler for airline style syntax, and it does this thing. When you call a match expression like this, right, and you give it a byte string and you give it patterns, it actually parses that, compiles this to a series of expressions that check the buffer as cheaply and efficiently as possible, and then you even get like types for the different parts that you're reading. Like these are ints, but this is like string, right, and stuff like that. So you can use that. And I'm trying to make this as easy to read and use as possible. Yeah, I hear you. The moment I started writing more networking protocols, like parsing of strings and stuff like that, it's like no, I'm not gonna use parse combinators, right, to do this. I'm not gonna implement a parser from scratch. I really just want to grab that string and be like, give me this many bytes, right? That's it. That's all I want. But I also don't want to do the operations that this does because this stuff compiles to some nasty code, right? I think I have an expanded version here. Yeah. That stuff compiles to this. You have all of these operations for extracting values, right? And then if we fail at some point, because the first pattern match in the match failed, then we go to the second one. And then if the second one fails, we go to the third one, right? Stuff like that. Yeah, man, I'm trying to make it so that you come here and help me build this network stack. Damn it. This is how far I would go to work with you. All right. So right now we were fixing something. Yeah. The error that we get when we have an invalid size. And we can try this on the PPX, but unfortunately PPX is, I need to do work here so that we raise errors more nicely. Because right now, if we do another string like this one, right, and we say UTF-9, this fails, but it doesn't really tell us why here. We just see a horrible exception here. So cool. Good to hear. So what was the problem? Right, the problem is that we had bit somewhere here. In the byte, actually, like that. And this is not valid, which is fine. So we'll search for everything that is byte that ends like that, right? And we'll do bytes. And we search for anything that is byte and has an open parens. So that should get rid of that error. Perfect. We are back on track. Okay, so I need to stop doing that. It's just a reflex by now. The accents get all messed up. What do you do? This is ocaml. Same here, right? Nice. So that worked. We want the same two tests in the construction phase, right? So we'll add them here. Of course, we don't know what to expect. And over here, we're going to add them everywhere else. And we're going to go to the lowering of the byte string construction. So we want to see what the output of that would be here, right? And I'm going to go oh, right. Cool. Tell me test. Tell me what to do. So bytes, foo, right? And this would be ocaml. And the source should be a string, so the printer is broken there. Let's search for that and fix it. Cool. Back to the test. Have a good night, Ryan. Take care. Not bad, not bad. This is complex, but it does exactly what we expect it to do. So it calls foo like that. Then we have by 8, and then, yeah, sounds good. Sounds like it's preserved. Whatever nonsense we wrote there, it's going to type as regular ocaml. And here we'll do ocaml. Same thing here. Leia, why are you standing on the phone? I can't see anything. Yeah, you can do that. Another Vim or NeoVim pet peeve I have is that for control I, for swapping between buffers like that, it must die. Because I never want to do that. I always want to press control U, right? But sometimes I is closer, right? So I accidentally type I. So I need to unbind that. Cool. Come on, almost there. That also makes sense. We're getting the next amount of bytes. No, Leia, there's a plate here. Oh, are you okay? No. Oh my God. Flashbacks to the Lion King. Oh, she almost threw this plate, right? So I extended my arm to grab the plate on the back, right? And then she starts sliding over. And I just see her little eyes just like go big black pupils with her hands just on the table hanging from it. Jesus. The next scene in my head obviously is like, "Long live the king," right? By Scar. Which I didn't do. She jumped, but Jesus. And that, it looks like we're good. All right, we have that thing. We have tests that allow you to put weird arbitrary expressions in there, and that's fine. And that means this over here, where we do compute bits, should work. And if we check the expression of what, that's an exception. That's weird. Compute bits is a function from unit to that. So I believe that if we do this, then we can check that, and that should be, no, come on, seriously? I mean, it compiles fine, it's telling us the payload is not being used, the mask is not being used, which is fine. And we're not using the rest. I really like that though. Hey, this is something you're matching on that you're not using. Actively ignore it. Okay, so now that we have that, we can go into the interesting part, which is how do we surface errors nicely from this thing? No, honestly, I can't. I wouldn't be surprised if they managed to do something just like this, right? Somehow at the type level, they extract information from strings, but yeah. I think it was a big missed opportunity there not to enrich the TypeScript ecosystem by allowing like pre-processing of things, essentially macros. Macros can be terrible, right? But also they allow us to do amazing things like this. It's like I really just want the code to be more declarative. And if we're being honest, I think this should be syntax in the language. So the goal with this stuff right now, beyond all of the Riot things that we want to do, right, is that if it works and it works well and is very much more ergonomic, right, than the alternatives, which I really believe so, but I need more data. I need other people to also believe that, right? Then I will make an actual proposal to the compiler to add it. So maybe, hopefully, soon, one day, you will get to do this, right? And that will be a pattern matching on a regular match, right? Most likely, before we get there, we will do this as a dialect. So then, this is also, maybe you've seen a tweet where I was asking for multiple, multiple dialects using the same extension. Somewhere in here, dialects. Yeah, here. And the reason for this is that I don't want to make a new extension, right? I want to use the same extension, right? And I want to just be able to pre-process all the files, right? Before ocaml takes care of them. But I also don't want to manually add a pre-processing step to everything, right? I understand the value of saying we have this build graph that has thousands of nodes. We just can't afford to run this byte string thingy, right, on everything, right? Because maybe it's a considerable overhead for a company like Jane Street. But if the default is that you can enable one of these things for everything, right, then you get this byte string for free everywhere, right? And then if at some point it becomes a pain, then you can either actively disable it from somewhere or just flip it and say, okay, I'm going to just inline all the preprocess and whatever, right? But that still doesn't solve the problem that you have to do this weird, funky-ass byte string matching, right? So most likely the dialect will mean I'll be writing Riot code in something called like Riot ML or RML or something like that, which I don't really like. I want it to just be regular ML, right? And then we'll be able to pre-process that file. So if we find a match, and if we find that the match has this thing, then we'll turn that into this. The nice thing of doing that is that we can do this also for example, function headers, right? So if instead of having a match string, a match expression, right, you wanted to do like match on, fin one, right? Rest bytes, then this will be a valid function header, right? And it will either match on this thing or not. And then we can translate this thing. Exactly, you structure the input. I'm okay right now with not doing this and allowing people to say like input, right? And then match byte string input. But if effectively, I don't want to do that. This is a lot of ceremony for something that is very fundamental, I think. Like right now, we do weird things. We do split on char, right, on a big string, and then match on lists. And this is just ridiculously inefficient, right? If you have a large string, I'm not, whatever, whatever size you want to use, splitting to chars just so that you can get the head of the list, right? It is stupid, right? But that's what we do. The alternative thing we do is that we actually use substrings, right? So you get the whole string, and then you do from 0 to 10, and I'm going to pattern match in this thing, right? And the string and bytes implementations are pretty good. Like, if I don't know if I can judge them, but from the code I've read inside them, they're like really nice. And there's only very little C also in them, right? Most of them is just regular ocaml, which is kind of nice. Xavier is the GOAT. But I would love if we didn't have to think of that. Because then we can make this string matching more and more like optimized over time, right? And hopefully make a lot of applications much faster from the get-go. But I think I would be okay with this even being part of the regular string syntax, right? Like if you have a match, then this is how the match behaves. I don't think that will fly, right? But introducing a new kind of sigil for strings, something like this. Probably this one also won't match because this is used in a lot of operators, right? Yeah. I don't know. I just feel like this stuff is pretty nasty, like pipe brace. Anyways, rant over, back to work. So we have the new syntax supported. We can do arbitrary expressions. That's pretty amazing. Love it. Cool. Now we want to do actual optimizations, right, in the lowering representation. Because right now, we take a single expression, right, and then we try to lower it. So showing the test here. Essentially, we grab one of these things and turn it into this, right? What we want to be able to do is pass multiple of this together, right? And create a representation, right, that is optimal for matching on all of them. And we can do that using this data already, which I think is great. Essentially, if we receive sets of these operations, then we need to say, okay, what are the common steps, right? What is the prefix that we want to read that is the same, right? So, for example, in this example, right, there is one bit, right, that right now determines what direction to take. Like the first choice we make is on the third and fourth bit, right? So first and second bit are the same for all the patterns, right? But the current implementation actually reads these two bits twice or every time. Instead, what we want to do is sort of say, okay, I'm going to read the first beat, right? And then I'm going to read the second beat, right? Because those are the prefix, right? If I can't read any of this, then I'm going to jump to another branch, right? But if we can't read those two, then we can do the try and try to read the third beat, right? Expect 0, right? This one. If we can't, so with no match, if we have no match there, then that means we need to jump to the first branch that does not have that, which is this one, right? And in that case, that branch will just do fin plus comp, right? Just return that. Obviously, this is a bigger try. If we cannot even read the first bit, then we go back into the other no match here, and we return that. Now, if we read the first bit, the first zeros, right, which is good, expect 0, then we can go into the next one, right, which is expect 1, and then we have another 0 here, and then we have 127, right? And at that point, we can check. Try 3, listen to me. If we can read the length, right, read something, then we know we're going into this branch. But if we don't, then we know we're going into the next branch, right? And so on and so forth. So that is what we want to do now. We want to grab a series of this matching lower representations, right? And build a prefix tree out of them so that then later we can compile that to code that is much more efficient than what we currently have. And most languages have very complex implementations. I mean, most languages. Elixir, Erlang, right? Of this pattern matching compiler. Ocaml has its own pattern matching compiler for the match expressions, right? And it's also very complex. So we're not going to look into that. Right now, we just need this to be a little better. We don't need it to be optimal. Like, nobody's using this. I just don't want it to suck from day one, right? So if we do that, then I think we'll be in a good spot. In the meantime, Felipe has been working on the actual underlying implementation. And this is what matters really, right? Like, I'm building all of this nice usability focus, right? DX focus tooling so that you can do the pattern matching and do the construction and so on. But none of this would work without an implementation that supports it, right? And right now, Felipe is building row-based, I think it was a row-based immutable string, right? So a string has a representation, right, which is like that, where you either have a flat string or a chunk string with different ranges, right? And it has some really interesting properties. Seriously, I love this PR. I'm going to drop that on chat. We're going to go out of the, just want to see the unified split diff. Yeah, thank you. Apply and reload. And we're going to hide white space. I just want to see the entire file. No, really? Does that? Okay, at least we can read these invariants, separately. It is tunable, so we have a way of actually checking, right? What is the smaller string that we're gonna consider keeping on its own versus sort of amending it to the last known string up to a certain point. And right now, I think it has a single mutable bit, which is the bleating. This is so cool. And we have a version of toString. So if you have a chunk representation, we would actually go through, right, that chunk representation and create a new string out of everything. So you would normally not use the string, right? Because this is gonna be the point where you escape the byte string, right? Let's say for interrupt, that sort of thing. Um, I'm not I'm not happy with the string situation in ocaml at the moment, especially not for like big strings. Hopefully this will help us maintain all of the string work, right, inside of Riot to byte strings. So if you build things on Riot, then you will be using byte strings everywhere. And the only place where you would use string would be when you do literals, right? So when you do like quotes to write the string manually, or when you interrupt with all the libraries that require a string. And even then, not right now, but at some point, I would like to see if we can find a way of using an internal representation that is compatible enough. So when you pass in a byte string, right, we can have a function as string, which is really just a typecast. Now, I understand that's not going to be the case because of the chunk representation, right? Because these chunks are definitely not going to be laid out in memory the same way as a regular string. But yeah, just trying to find ways of saying, okay, you still get to use the same string that it's efficient, it has built-in pattern matching on it, right? But you can pass it in anywhere you need a string. It might be an interesting piece of engineering to figure out how to do that representation in a way that matches what ocaml has. And if you go into ocaml here, ocaml, and if you go into the string module, right, we have a type T, which is just called string, right? But we don't really see the internal representation. So this is defined in C. No, actually, this will be bytes, right? Bytes ML. Yeah, this is an intrinsic type. It's part of the compiler, so you don't need to define it. Hey, Mohaidara Sheriff. So pattern matching is when you have an input value, right? Like username, right? And we want to check, right, if the name is Dylan, for example, right, then we do something. Or if the name is Bad Cop, right, we do something else, and so on, right? So it's a way of sort of checking a value to conform to a pattern. For strings right now, so it's like a big switch, if you want to call it that, or a more expressive switch, like a switch on steroids. For strings, however, pattern matching in ocaml is a little limited. So you cannot do things like matching on a prefix, right? You can only do things like, this is the whole string. Is it? Yeah. Okay, cool, right? Or you would say, if we want to match on the prefix of a user, then we're going to split this, right? Actually, to sec, and oh my god, this is pretty terrible, right? We will build a string of a list of characters, and now we can check, right? If this is going to be Dylan, right? Oh my god. Dylan, let's say if it begins with a D, right? Then we do something. If it begins with a B, we do something, right? And so on. What we're building here is a way for you to say, okay, I'm going to match on the username, and I want the username to begin with the letter D, right? And then I don't care about the rest, right? Like that. Without having to do this string to list conversions or anything like that. Unfortunately, ocaml is not that extensible in syntax-wise, so we need to use this syntax to express that. Which is not so bad, but could be much better. So that's what we're doing. This is pattern matching. Okay, so I think I'm gonna add a new. We have the intermediate representation for compiling a single thing, right? And I think that's great. But I think I'm gonna add a new pass to this compiler, where we're gonna grab the pattern matcher, the matching, the lower representation, lower. Yeah, in this case, it only applies to strings because ocaml has us covered for other things, right? If you have objects or records, you can do that just fine. But it's string where we have a little bit of a problem. In fact, I think I'm going to reuse the matching lower that we currently have, right? Because we will need exactly the same thing, except that we will need a few more ops here. So if we look at the generated code, we have this try, right? And we have a catch here as well. And we would like this to exist, but to look differently. No worries, Mo. All good. Yeah, it's on the same sort of category of language features. It is much more powerful, though, because you usually can use patterns. In which cases, you can just say, normally, you can just say, like, is this exact value? Is it the number 1? Yeah, okay, do this, right? So how would that look like, right? If we have this as our expect, like this is the thing we're testing against, right? We want to you know what? Let's move the PPX code first. We write a test and we start playing around with that there. So PPX byte string. It's not even that much. It's just this little bit, right? And the fact that we wrapped it in a function like that. Okay. So by pattern, right? We'll do to pattern match. That's fine. We'll do to match. Okay. Well, I guess we do that. Correct. Generally speaking, pattern matching is more powerful. So we can move that code here. The hell did I put the code here, right? So you will have branches. which means we don't need just patterns, we also need the bodies the patterns match against, so we can put them in the right spot, right? That's fine. We can do patterns and bodies. No, I think it'll be easier to just get patterns, and this would be a list, right, of an expression, or pattern and expression list. Wait, what is a pattern? No, we don't need a pattern here. We need construction lower T list. Matching lower T list, yeah. Nice. Scala is super powerful. A little too powerful, if you ask me. So how do we do this? We have the expression and we have the matching lower, right? How do we want to use it? We want to be able to just say, here's the cases. For every case I'm going to pass, I'm going to get a pattern match. So I'm going to end up with a by pattern and a body, right? Which is fine. So we need that. And then once I do that, I will call by pattern to match expression, right? And I need the lock, I need data, and I need the cases. And then we'll do this thing there. Okay, that sounds good to me. So now we can do let cases. It's gonna be patterns, list map, right? And then here we'll get the by pattern and we'll get the body. And we can run that thing. Cool. What don't you like? So in this case, we don't actually have... Oh yeah, we do need to call that. We can go to expression. Cool. And if you give us the data, then we'll also put the data in the right spot. Perfect. So now we can call that in a test. Nice and easy, right? We can go, I think the pad one, this one, we can use this one as a base. But we don't really need single tests, right? Because we want to call, so instead of string here, right, we'll get strings and we'll do list map over all of them, right, to parse them. So we get by patterns, right, lowers. And then we'll say to pattern to match expression. Did we expose that? No, we did not. And I get a feeling this will grow, so we might want to put it in its own module. But right now, let's just make it work. To matching, okay. Fine, fine. And then data is going to be the thing. And data is the input to the whole pattern, right? Because you already have everything else that's happening. And we are inside of a bigger expression, so we don't really know what's happening afterwards, which is fine. Cool. that's fine. So the type we have here is wrong, which is okay. Just let the implementation decide. It still doesn't like it, okay. Cool. So we will start nice and easy with our zero test here, right? And we'll give it no strings or one empty string. I guess we need at least one, right? We could do two. And we'll do doing test on that, and we'll see what we get. So line 704, this doesn't like that because it should be strings like that. And then lowers, what don't you like about this? Right. No, that should be fine. We get several match expressions, right? Like a list of the expression in the body. But lowers is not that. I guess in this case the body doesn't really matter, but we do want to have the tuple. So something like that makes more sense. Cool. And this should be D. And then strs. And we'll do number, and then we'll do D here. Hey, thanks for the follow, standard format. Nice. Okay, so love this because now we can actually test this stuff, right? And start playing around with what the final representation would be, right? So that should pass. We can format the whole thing. Come back here. So this should probably be an error, right? But if we do rest, if we do hello and world, and we'll make this 8 bits, and we'll make this 10 bits. Oh, this wrapped everything. What the hell? That's weird. Cool. So then that's gonna blow as well, but it's gonna give us a different, right? Generate the code. So what does it give you? It first tries to get, I think this is the smallest one that we can try to do some work on, because we want the iterator, right, to be shared. So we essentially want to pull the iterator up there, right?
And I think just for sanity's sakes, we're going to include in the body, right, the number. We're going to do test like this, ID, and it will be test, right? And then we can put the number here. So int to string, I think we don't have that. That's also a PT. String of int n, right? Cool. So now, okay, maybe we even want to do more than that. So when we do tests like that, we will do a map I. So we get an index, right? And we can see the different bodies are going in different places. So this will be test, and then we'll do body, right? String of int index. But I'm gonna grab that entire thing and I'm gonna say like test name. Whew. So it's not so terrible. Cool. So test body 0, test body 1. That makes sense. So test body 0. And if we put that back in there, then this should pass. Cool. Okay, folks. Let's begin optimizing. So first, I want to get rid of the actual generation of this expression. And first, and before, right, put a layer where a try, right, of a match and the exception of no matching, that is represented as an operation, right? Because right now this is happening in the code. And there's the implicit assumption, right, that we try a match and it will blow up, right? And then if it does, we will just wrap it with a try, and in the catch section, we'll just call the next match and so on. You'll note that at the very end, we're just saying like, okay, if you get here, then we'll just raise again, say no match. So this match probably will, yeah, it's fine to use the same exception here. So instead of doing a fold like that, we want to be able to do data that says we're going to try, right? Of, and then we'll get a list of operations, right? With, and then we'll do the fallback, the rest, right? So if we represent that as part of the AST, then it'll be much easier to just traverse later and say, oh, we have a try, great, we'll just do a try, and the body will be the body, and the catch will be the catch, right? But it also means we can move things inside or outside of the tries and so on without having to operate on the syntax tree itself, because the ocaml syntax tree is complex. These are the types, right? And I'll just keep going. Has tons of crap. That's 1,000 lines, and this is just type definitions, right, and comments. If we sort everything, right, and get rid of all the spaces and all the comments and stuff like that, okay, so sorting broke some things. Never mind, bad idea. Shouldn't have done that. But we can do clock, right? And we can do f parse tree mli. Oof. So roughly half of that, right? It's types. Big types. Okay, so how do we do this? We have a pattern match, and we have a body for each one of those. That's good. So I would like to first, now that we are on music, just gonna go back there. We can play again. I feel like this soundtrack starts on high and it just gets low. First, I want to find the prefix, right? And so I'm going to do a map over the list. No. Yeah. So I want to find the prefix, and then I want to go into every one of the byte patterns and strip the prefix from it, right? Because the prefix should be somewhere up. So we kind of want to build that tree that way. I wonder if there's more efficient ways of doing this. I know that there's a data structure called try, right? And I think retry. Yeah, of course I would like to use operators like that. Cool, so this is a try over strings. It is pretty crappy, but it might do the job. Now we don't want a single try because we may have different roots, right? So I wonder if we need a trio trees here, right? Where we have a top level tree and we can start by saying, okay, we'll just put the first operation there, right? And this sounds like a very stupid way of building it. Maybe it will work, right? So at every level, right, there's there's another hash table. So there's a hash table at the top that has the top level operations, and that goes into a hash table, right? From operations to like essentially this, right? Type T is going to be a table, right, of an operation, so like a matching lower T, right, into another one of this T, right? So the last one is an empty hash table. But otherwise, what do you say, chat? I'm happy to also pull up a try paper or look at an existing ocaml implementation and just grab ideas from there. But the goal here would be that we would go through this list, like lists of things, right? And we would essentially insert, right, all of the stuff. So I think we just need a distinction between a node and a leaf here, right? So here T will be our type node. And we can make this recursive, so and node, right? Either it's a leaf, and if it's a leaf, we have a parse tree expression, right? Which is the last thing that's going to happen. Or if it's a node, right? Then we have a T. I wonder if we can get rid of the hash table entirely. I do like the idea of having a hash table, right? Because we can make these lookups really fast. But ultimately, we want to build something that maybe at any point, right, has a list of matching lower T, right? And Maybe this will be enough, right? Oh yeah, the language does have pattern matching. We're adding pattern matching on strings. So I think if we still have the buffer somewhere, maybe we don't. No. You can do pattern matching on variants, on structs, right? But, and it's super, super powerful. But right now on strings, it's very limited. Either you match the exact same thing or that's it, right? So we're adding the support for pattern matches like this, or even easier to see, like that. You pass in a string, so you can check, you know, if the first bit, if there's a bit number one, and if there's a second bit, and if the third and fourth bits are 0, and the next 4 bits are 1, right? And so on. Then run this branch of code. Else, look at that. Else, look at that. Else, do this. So maybe you've seen this in Elixir or Erlang, maybe? That's the same idea. In fact, this syntax is heavily, heavily inspired by Elixir. And right now we're just trying to make this pattern matching, this process, right, better. Oh yeah, like the reason we're working on this is that I was building an HTTP server for a runtime and a multi-core runtime for ocaml that I'm building, and I had to write a parser, right? And this just made it so much easier. There is an implementation of something like this right now that is very clunky, I feel, and it's not gonna. It's very unergonomic, and it's also a GPL license, hasn't been maintained in a while, and it has its own kind of strange internal type. So you find yourself converting things in and out of that type all the time. So the idea with ByteString would be that it would make parsing protocols like this one, right, just ridiculously easier. So we would literally, it would become this, right? And you need to annotate the bytes at the end, but like that, right? And everything uses the same string type all throughout, right? So you don't have to like think about that. If you're working with bytestrings, then you're working with bytestrings. Once you're done working with bytestrings, then you can move on to regular string if you want to operate interrupt with other libraries and stuff like that. But at least on the runtime I'm building, then the bytestring will be the type. Please explain and confused. Do you have any specific question? I'm happy to try and answer. This one? Oh, okay. I see your point. Yeah. So you know how I don't know how familiar you are with ocaml. I'm gonna assume you're not, but I'm just gonna go with all the languages, right? You know how in let's say JavaScript, right? You define a function foo, right? And then this function can call a function bar that's defined later, because the function definitions are also sort of like hoisted up. All the languages have similar things. This also is not evaluated, right? The bar call until all of the program is executed, right? Parsed and interpreted and loaded and whatnot. In ocaml, usually we write definitions, right? Let's say let foo, so that they will be available for later definitions. So let bar, right? And in this case, in this case, no. Just you're getting way ahead of time. Like, be patient. Foo here cannot call bar, right? Because bar is defined after foo, right? OCaml enforces that you define the things you need before, right? So if we wanted to write that code, we need to do this, bar and then foo. However, this sometimes means that if you want to write a lot of code, right, with a lot of functions, you need to start at the top with the smallest functions, right? And for some things, I find this very counterintuitive, right? Now, if you wanted all of these functions to be able to call each other, right, then you would need to make sure that these functions are what we call mutually recursive, right? So you will say the first function is recursive, right? And the second function is recursive, and the third function is recursive. And then that means baz and bar and foo, you can call them from all of them, right? Like that. So in this case, parse calls do parse, right? And I kind of want all of these ones here, they have to call each other in some places, right? To be mutually recursive, so I can read the parser from the top down rather than from the bottom up. Hopefully that makes some sense. But this is not like the result handling. This is a function definition. Oh, thanks for the follow, Spikes Bats. Mutual recursive, you know how a function can call itself? Like function A calls A, like that. Mutual recursive would be two functions that call each other. A equals B, B equals A. Obviously, this is a dumb example because they just never finish, right? But you can see how, for example, a way of changing definitions. Don't talk to me, I have an ad. All right, sorry. I need to get back to this. Let me just undo the changes. Boy, we're gonna make this much nicer. Anyways, back to Riot. So what we're trying to do is grab that series of patterns and build a prefix tree over them. So then we can go through the tree, right? And I think that as long as we might actually want to have multiple. So let's see how this will look like. Right? We will have something like node, and then we'll need. Let's I'm gonna move that for a second to the test so we can see more clearly here, right? We have a node, and the node has to be a create eater, right? So that will be the first thing. But we may have many things here, right? So in this example, we just lift the creation of the iterator, right? Which is fine. And then the rest of what we're going to have, right? Okay, so I think I'm going to make two lists instead. So the first one defines all of the operations that are shared up to this point, right? And then the second one defines all of the different branches that we have, right? And what I think is that the branching point there, that's going to be a try catch. So in this case, we want to run, right? We want to run parser or, run the first one, right? And then the other branch will be run number 2. That makes sense to me. So we can fold over the runs after we generate the code for the first one. But this one over here would actually be, since it's a list of these expressions, right? It could be the same. It could be that maybe we want a slightly more complex example here. So if we do hello 8 on that one, right? But the first one also has a world here, right? Or by. Then this will become a node, right? Where we would have a shared expectation on read hello, right? And then we will have the branches. And one of the branches will be run, right? Will be essentially okay, I think the lifts are going to be a little more complex than that, right? If we have a lift, then I think it makes sense to have all of the expressions there. So here we'll just say leaf, right? This will be one leaf. I know it can have multiple leaf points too. And the first thing we'll do here will be essentially this stuff, right? But for by. So we read byte number 2, right? And then that will be the end of the operations in that leaf. And then the body of that leaf will be our call to test body 1. So what the hell? Test 1 body 1. So I think it will look something like that, right? That way, if you have, let's say, byte 2, other 3, and byte 2 here, then that means this call to read byte, right? This one over here will move up. So we can read that for both of these branches because we know that both branches need it. And then this is one leaf, and then we have another leaf here that essentially has no operations, right? Which means all of the things we did are already a good match. And then it has test 1 body 2. Or actually this will be body 1 and this is body 0. I'm pretty sure there's better ways of doing this. And that will be one node, and then the other node here, right, is actually a leaf. because he has no share stuff with anything, and he's just like read world 10, right? And then we do test 1 body 2. Okay, so chat, what do you think? That makes sense to me. Does that tree make sense to you? Because if it does, then before we do these tests with the final ocaml code, we will test against this tree representation, right? So we will generate that tree, we'll print that tree, right? And if we do that tree right, then it will be trivial, right? To turn that into ocaml code. Boy, I love compiler so much. Cool. So I'm going to move that a little lower here. You know what? Yeah, we're going to do another module, and we'll do optimize match. And then pattern matcher, right? Oh, thanks, Miner. Thanks a bunch. So I think we want an operation here. Either it's going to be, like I want to add specific things for calls, right? Thanks for the follow, JLPB. I want to add specific things for running a parser, right? Running a matcher run. And essentially that would be one of those. We can even do try run, right? Because that's the point. That is this point, right? Where we have a leaf and we know that we have these things. But I just don't like the leaf terminology, right? So maybe we can do prefix. Yeah, I think this makes more sense. And we can call it T because we're constrained by the module. So either you have a prefix of operations that you want to run, right? Or you have a try run, and the try run is like the last bits, which is like, okay, this is the last things you want to call on or do. I think the interesting part is that this now avoids the matcher function that we were building around before. So if you look here, for every expression, we actually had a matcher function, and that now this means we can't do that. But we probably want to define this matcher function outside, right? Like an anonymous function like this for the whole thing. And then we call that with the source data. So we don't have that. We have this. Yes. Yes, this makes a lot of sense to me. I hope it does make some sense to you too, chat. But if you don't, well, too bad. Ooh, here's a crazy idea. What if we make these patterns, right, functions? So if you say byte string here, that actually becomes a function. So you can literally do this. And that's a function call that we try to, this is a terrible idea. Never mind. I think we probably will want this to happen in a let instead. Like that. Right? So if you do that, either you match or you throw a no match. I just really wish it wasn't so verbose. So much nicer. Anyways, back on track. So we do to match expression. We actually want to iterate over. So the dumbest thing we could do is to make every one of the patterns and the body, right? Wait. When I do the pattern match, I think we might be a little too late here. So I actually want to lower the patterns myself. Yes, that makes more sense to me. So we just parse and we get the byte pattern list. That's perfect. And then we lower it ourselves. So now we want to turn that, each one of those, right, into a prefix tree. And then we can merge the trees together. And this will be a very dumb implementation of this. But hell, this runs at compile time. patterns are usually going to be very small, anyways. Like, you're not going to have a million lines of pattern matching code. And if you do, then I'll fix it. If you do have a million lines of pattern matching code, I will make this so fast. But the condition is that it has to be running on prod. Or it has to be blocking you to run it on prod. Otherwise, it's probably going to be fast enough. Okay. So these are cases, and they're all instances of that, right? Whereas I kind of want to build prefixes. So how do we do this? Do we zip the list together? How did we do this? Because we did have an implementation here, right? So unfortunately, this implementation is adding tries one at a time. Okay. Let's search for hat try. I'm gonna regret doing this. This is C. This is C++. Radix tree. Hey, hash buckets and associative arrays. Lookup, deletion. Let's go to the ocaml AI. I have two lists of type operation, and I like to build a radix tree with the following. Okay, so not that different from what we had. So this is doing insertions, and then we have a hash table. I don't know if it's good that I thought of the same thing that hash GPT, that the ocaml genie is saying here. Here's my tree type. Give me a function that takes operation list and turns it into a prefix try with this type. Okay, so this is going to be building the try by folding over the op list, right? Reasonable. And we have a common prefix function here, and this is working on strings. But if we do, then we don't have sub here anymore. But the common prefix, we can build that. Okay. So we need, given two lists, we need to see if the prefixes are the same. So we'll do prefix, right? And if you give me op1 and op2, right? Then we'll just match an op1 and op2. If they're both empty, then it's empty. If we have an element op, right? And an element 2, rest 2, right? Then when element 1 is equals to element 2, and this is when it's going to get a little nasty. But maybe it's okay because we don't want to have the parse expressions be equal at all. Okay, so if they're the same, we're going to do prefix, right? We'll return L1, and then we'll do prefix rest1, rest2. So this is rec, and actually we can do tail mod cons here. Cool. If they're not equal, right? So the case here is where they're not the same. Then actually the only case we care about is this one. Everything else is just going to be, okay, we found at the end of the prefix. So that is it. Rest 1. And we can call this h1, h2, head 1, head 2. Actually, element's fine. No, I don't care. Why are... We don't say that word in this chat. No, it's okay. I don't care. It's fine if you can use it. I think it's a cool editor. It has a lot of nice little things. I'm just too used to Vim and NeoVim, so this is what I use. No, I'm not gonna spoon feed you Vim. If you don't want to use it, don't use it. That's fine. You can, Spikes Pass. You can ask me. You can also just go to my Twitch page, right? And just like look at how often I have streamed. Oh no, this is gonna be terrible. Um, Videos. Where the hell are the videos? I don't know where the videos are. But you know how to look for things in Twitch, so you can see how often I have streamed. More recently than before, but whoa, look at that. Infinite screen. Anyways. So now that we have a prefix, we can just start folding these things together, right? Cool. I'm also trying this new camera placement, but I get the impression that when I'm not looking at it for a long period of time, like when I look at chat, for example, right, it goes dark. And I don't see that, but I see it when I raise my eyes. I get the little sort of visor in the camera here, right to the right, and I see it like slightly glowing. So it might be a good idea to just like lower this. And it is actually standing on a Dune book. Nice, right? So I think what's going to happen here is that I'm going to actually return. No, I don't need to do anything there. Let's do merge, right? And we'll take two lists of operations and then a body one, and then an op2 and a body 2. And here we're going to find the common prefix, right? And that will just be a prefix. And then we'll put each one of the bodies. So we'll do match prefix op1, op2, right? If we have some prefix, if we don't have any prefix, then that's fine. We will just return prefix. Actually, that's fine. Prefix, like that. But we do need to have the rest of one and the rest of two, right? So this should just recurse building that list. No, we're gonna need to do something else. Right, so this is the unique parts of one and the unique parts of two, and then we just put the prefix on top. So here we'll just return op1 and op2. And I think this doesn't need tail modulo cons anymore. It should complain. It does not. Okay. So we can do a prefix, right? And then put the prefix there, and then we'll do a list, and then we'll do try run, right? And then we'll do op1, and then body 1, and then try run, op2, body 2. So this will build a prefix from 2 of them, right? Hey, Spax, do not worry. That's completely fine. I am just streaming for fun right now. I don't make a living out of this. It doesn't go into my sort of accounting or anything, right? So as long as you're enjoying, the follow is more than enough. Don't worry. It's completely fine. I appreciate, though, the intent as well. Cool. So now if you give me 2 of those, I'll give you a T, a prefix, right? So we can start by having a function for making the prefixes. If you give me the patterns, you do that. So that's the function we could test, right? Because this little function here, it's pretty easy to build a pretty printer for. Either you have a prefix, right, and you have like ops, and then a T, right? And it will be recursive because this is a recursive data type. And so we can do format, printf, format, and we'll do prefix, right? And then we want the ops here, so I'm gonna put A for rendering those ops, right? And then we'll put a T, so that will be also an A because it is this very pretty printer. And this is gonna look terrible. Just give it a sec. And here we want to do matching lower PP we have for printing many of them, right? So we'll do ops, and then PP for T. And now we also need to try run, right? And here we have ops, and then we have body. And then we can do try run, and then here the same thing. And then we have the body, and the body is also, it's actually going to be a string. So we'll do matching lower PP, and then we'll do ops. And then for the expression printing, let me put a marker there. We will do this thing. There. So we will turn the body into an expression, and we'll just put it in that in there. I guess this will be PP1 when we have one of them, right? And if we have a list of things, then we'll just do this listed thing that we did before. Cool. So that should be there. Let's see how far off we are. 8, 6, 7. We can really compile it all. So we remove that. What else is missing? Line 818. Lower is broken. Let's see what we changed. Oh, okay. So we definitely broke something here. We want this change back. Keep testing. 868, 66. Right. No worries. We don't want this function just yet, right? To prefix match. I want to do that. So we have merge, which will merge 2 things. And we now want to merge everything. So we'll grab 2 things and then merge those, and then grab the next 2 things and merge those, right? I wonder if we should sort the list by the smallest, right? Or maybe we should be a little less smart and instead of having a prefix with multiple operations, right? We just have a single operation everywhere, right? So that means turning one of these things into a prefix, right? It's you will end up with prefix A of prefix B, right? Of prefix C, and so on. But my gut tells me this will be a little easier to merge later because this is essentially a list, right? So our merge function will be pretty much the same. And what's better, right? We could build a prefix at the very beginning out of the operations, right? Never mind. Let's try what we have. Let's see how far we can go. It might be that we break in the middle. But okay, so now we want to do list fold left, right? And in there we'll get our A and B, right? List 1, list 2, or prefix 1 and prefix 2, right? And we just want to merge those. So unfortunately, our merge function is currently working on these things. So we may want to fix it so that merging works at this level, right? Let's see. If you give me 2 try runs, right? And this will have like up 1 and body 1, and then try run up 1, up 2, body 2, right? Then we'll try to find a common prefix across them. Oh yeah, I love this because then we can call, we can just do a try run here, right? Like we set up everything to be a try run, and then we start extracting things out of them. Oof, yes. Let's see if this will work, though. So, all right, if we have that, then we can do our tiny little thing here. So when we do have that, then we will try to find a prefix, right, and get the rest of the operations, and essentially pull out the prefix out of those 2 try runs, right? When we have a prefix and a try run, right? Hmm. Hmm. So in this case, we have a try run, right, and a prefix. And what we would like to know is if up2, right, is contained within this prefix. Right? So an example here will be prefix, and then we do read one, right? Read two, and then we do other things, right? Whatever. And we have a try run, right? That essentially says read two, and then we have some expression there. And the outcome here should be prefix of read one, right? No, this should not be a prefix. But if this was read one, right? Then we want the prefix to be read one, right? And then we want the operations to be prefix of read two, and then whatever we had before, and then try run, right? With essentially nothing. Like that's what we would want to do. So my guess is that we will primarily operate over the ops here. And only if we do find a prefix between the ops, then we do the rewrite. So let's try that. If prefix is empty, then there is no prefix between the two things. That is fine. How do we deal with that? Do we just do an empty prefix? That sounds like we'll have a lot of empty data structures everywhere. Okay. But then that sounds like this will work. That will be the case, right? If the prefix is not empty, however, right? Prefix here is now this bit. So we want to do prefix, and then the first thing will be a prefix, right, of up one and body one. Because we haven't really changed the minimum operations for this thing. And then try run is going to be up to body two. If we get two prefixes, or yeah, we can do that case up here. That should be easy. Easy mode, body one, prefix, up to body two. If we get two prefixes, right, then we just, I guess this is it, right? Same code. If we get two prefixes, we compare the prefixes. If there's nothing common, then we just put an empty prefix in them, right? And then just create two prefix operations here. So this would essentially be the same code, right? The same data as we have there. Otherwise, we do this. And because these cases are the same, then it sounds like that's what's going to happen. Which is kind of the same as this one. Now, there's one case, the last one, which is where we have a try run on the left and a prefix on the right. And this will be the same one as that one, but with the numbers inverted. So try run, and then prefix, right? If we find a prefix, then we do the prefix, and then we do a try run first and a prefix second. And it looks like this is going to be the same for both. So we'll do that. So this is the interesting case. No, wait. If there's no prefix between the try run and the existing prefix, right, then we still need to put them together, right? So we'll put a prefix that will be empty, and that will be like a root. And then we have try. Oh, we run out of music. didn't we? Yeah. So we come back here. I think this is the fourth run of the soundtrack. Hope you're enjoying it as much as I am. However, if we do have a prefix, then we want to do the same. No, this feels wrong. Okay, we're gonna try it. We're gonna see if it is as bad as we think it is. So now, why are we failing like that? All right, because we have all this garbage here. Cool. So now we can do fold and left, and we do merge, right? And then we'll start with a prefix that is empty, and we'll fold over our cases. Eight, 6, 5. What's the problem here? Right. The problem is that this body one, thank you type system, that really is a list of crap that needs to happen. So when we have an empty prefix, we just want to append to the list of things. No, wait, what I'm reading this wrong, aren't I? If we do have a prefix, that's fine because we can just like split the prefix, right? If we don't have a prefix, then we just want to keep things as they are. Are you serious? This looks like the same code all over again. Is this prefix function doing so much work? I'm pretty sure this is broken. Okay, so let's just make this compile. It will fail horribly soon, right? Actually, we can probably go back to what we had before here, so it doesn't fail so bad, right? And we can focus on the new test, not the old one, 711. Yeah. No, this is, I don't care about that. I don't care about this. I care about this one now. 711. And we don't have that, but we have to prefix match, which should not be an expression like that. It will actually be a byte pattern, prefix matching. Yeah, we need to BP that thing. And this doesn't need that anymore, which is fine. So actual, what's the problem? We have one of those. MPP, what does it want? Really? That gives us a single one? Okay. Cool. Great. We don't need this anymore. We can just do an empty list, and hopefully our crappy test framework will tell us exactly what's wrong. So expected is prefix matching T. Huh, not bad. There are a bunch of empty prefixes and crap. So let's do one thing. Oh, we will want to maybe fix the printing here. Never mind. We're gonna do something dumber. Just gonna copy that into the code. And this will be ocaml. Actually, ID. I tried muting, but I couldn't make it. Sorry. Okay. Not so terrible. It kind of looks like what we want, but oh my god, it is so terrible. It doesn't do anything. Just empty prefixes all the way. And the iterator is still there. Come on, seriously? It's a problem that we're doing equality checks. Like the equality check's not working. But okay, we have tests, right? Now we can actually start seeing it improve. So first things first, this one, the easy one, this should be easy to fix. We clearly are not merging things correctly when we do that merge function, right? And I think that makes sense because we start with an empty prefix, right? And when we do that, then nothing is going to be mergeable with the empty prefix. Unless we explicitly case it here, right? If we have an empty prefix, then whatever we do on the side, that's what we're going to return. So this looks exactly the same. No, this is the same. What the fuck? Okay, so that's working and that's not the problem. Eventually, right, when we return that, I think we should be running this thing. But we will do a little bit of logging. Our good old log function. And we do log, merging prefix with prefix. And yeah, this will be enough for now. Merging try run with prefix. Just want to see in which order we're getting these things. How the hell did we get there? We're merging two try runs, and we end up with like 4 different prefix layers. What's up, BJ Last? So we try merging these 2 prefixes, right? Not really using that. I don't see any other merging or anything here. So we're going straight there. So we should be skipping P1 or P2, right? Skip P1, and then we go into the merge. Oh, oh my God, I'm a dummy. I've been looking at what we expect, not what we found. This is what we found. put it there. This is exactly what we want. Look at that. We find a prefix that says empty data. We can change what that means for sure, but that is the prefix of both things. So remember before we had empty data on both, right? And then run the test body. And then afterwards we have the empty there right there. Oh, so mad. Okay, fine. So if we run the test again, then we should see what we get for the new one. And if we put it there, I think this will be exactly what we wanted. Fuck my life. Just spent, I don't know, a couple of minutes there, maybe a half hour. This looks beautiful, yes. Usually when you're writing ocaml and something doesn't work, it's your fault. Yeah, so this is excellent. This is exactly what we want, right? We have 3 branches. Of the 3 branches, there's one common prefix, which is the creation of the iterator, right? And then there is a shared prefix on the second and third branch. The first branch has one additional operation, and then runs the body. And the third branch doesn't do anything, right? It just like runs that body. Okay, you want to run that thing? Here it is. Here it goes. We run it. And the other branch only runs, right, if neither of these have matched, which actually will happen somewhere in here, right? Okay, so I think I'm ready for more tests. And many of these are very uninteresting, but we can run them anyways. I think actually we want the ones that have multiple things, like there, right? No, actually none of these would work because they're all on single operations. So you know what? We're going to bring in a big test first. This is tiny, right? So we're going to bring an entire actual match here. PPX test. We're going to bring this one. Nope. Yeah, okay, we'll do that. And then afterwards, I'm going to bring one from the WebSocket implementation I have. Format a code. Perfect. We can also just put that in a single line, and then we're going to break it up at length. There. Run the test. This is a little large, but we're going to compare that. PPX test. We're going to see what we expect. I think this is it. We have all of them, right, have a common iterator, which is created here. And then that makes sense. We do a bypass because we don't need an iterator, right? That explains why we have the no prefix there. Perfect. Hey Ria, I honestly don't know. I haven't done any node, and I don't know what backend you're using either. WebSockets, I can tell you can do broadcasts, right? As long as you thread the data and send it to all the sockets connected. But WebSockets themselves don't have like channels or stuff like that, like rooms or things like that. So all of these things are implemented on top of WebSockets, right? A WebSocket is just a connection between two machines that allows the data to flow in very small chunks there, right? So if you want to have a server that gets data and broadcasts it to everybody else, then at that level, at the WebSocket level, right, you have to deal with that yourselves. It might be the case that your framework in Node actually helps you with some of these things and has some abstraction like rooms or something like that. But I have no idea what framework you're using either, so I can't really help. Sorry about that. Okay, so we have fin and comp here, right? And they're up there, which is great because all of these three branches they use the same prefix. And now we have the next set of prefixes. Wait. Yes, perfect. So the last branch here, right, only needs this prefix, which is great. Now the other two branches in the middle, they have a larger prefix set, which goes from 0, right, till 127. There you go. And then after we get that done, then we try to run some of this. This is so nice. If we have all of those, right, up to 127, that means we can try to run any of these branches, right? And then we have done most of the work, if not all the work, right? To get those values read. So if we start reading this one, for example, right? Compute beats and whatnot, and we fail, then we'll jump from this try run into this branch. This is lovely. Okay, I think I want to add one more case, and I want to make that from the frame definition, right? Where we have this packet, and we want to parse that stuff, and it's kind of big. Right now, this is in bit string syntax, right? So we need to turn it into byte string syntax, which is fine. Sorry, I'm gonna close the one on the right. I'm gonna paste that in there. We don't support guards yet, which we will at some point soon. So roughly speaking, we want to do every time we see a column, we'll do double columns, right? If we see this, it's just going to be bytes. This is going to be bytes. This is going to be payload, right? It's going to be bytes like that. The commas. 32 bits, 37 bits, it's fine. 1, and we expect 0 here, which will be true, right? Opcode will be 2, reserved will be 2, we don't care about reserved. Same here, bytes, this will be bytes, and will be a custom number of bytes, so put a comma there, put a comma here. We expect 126. I had to do a check because I couldn't get it working otherwise. And this will be 0. And this will be 4, 2, 1. Cool. Don't know about you, but I think this is much nicer to read. We do want to have that multiplication there, right? We'll do bytes. No, we don't. We actually don't need that anymore. We can just do length by. Because another thing I did not like about bitstring is that different number of bytes actually fit into different integer sizes, and we might need to deal with that, right? And you may be screaming, Leandro, you cannot fit a 64-bit integer into a 31-bit integer. You are correct. We cannot. So most likely we will just make everything in 64. That's, by the way, one of the things that Go has that Rob Pike feels like maybe they should not have done. Just have a single integer type of arbitrary precision would have made life so much easier for everybody. Sure, you get some allocations here and there, but being realistic, if you were worrying so much about that, right, then maybe Go is not the language for you to write. What the fuck is the cursor? Okay, 7. I know Erlang doesn't have this problem either. You have arbitrarily large numbers by default, which is super nice. Cool. Okay, so now we have that. And now we have a massive pattern match, right? Which is okay. Oh, it's actually much smaller than I thought it was going to be. Format that, bad boy, formatted. And so when we do expression equals, we'll do expression equals ocaml. And then we just need to sprinkle some IDs here and there. I'm sorry. What? Why are you different? Oh, this is the other way around. Two, 4, 1, 7, data source everywhere, and then we have dynamic bits, and this is where things go wrong, right? We're printing this wrong. We do source expression ether like that. Cool. So the expressions will be ocaml code, right? And then we have a bunch of IDs. Why don't you like it? What is different here? So 01027 2417. So this part is cleared. Try run, right? Has a list of things here. So there. Bind next beat is len, compute beats, expression, and then data source is the same. Bind next fixed beats gonna be mask 32, data source, payload, len, and then ethers data source, and then we have rest data source. And then test 2 body 0, test 2 one body, test 2 body 2, source data source. So my guess is that we cannot see it because there is something wrong in the printing. So we'll double check the prints. Rest has source ether in this order, source ether, source ether, source size ether, source size ether, source expression 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 ether, value size ether, value size ether, value expression ether, value expression ether, value expression ether, value expression ether, value ether, value ether, value expression ether, and finally value expression ether. They're all the same. Why don't you like them? Okay, we're gonna do the dumb thing. We're gonna put this, what we found, right, in a file. And we'll do another file, which is what we think we have, which is this one. And we're gonna do a diff. That was useful. So, dynamic bits. I swear to God, I fixed this. What the hell? Oh, we're failing on a prior test. Cool. I mean, at least this test is passing now. But now we have a parsing error somewhere in here. So we'll start there. Let's see if we get... Yeah, that's fine. Next one. I think I know where it is. This should be a comma. Cool, okay. Nice, that passed. So we're gonna go into our little logs here at the bottom, right? And we're just gonna Whew. So let's go back to our PPX, right? Where we actually would do the work. And I keep saying that, but by pattern. Not the work per se, but like we will turn this into code, right? we would do that here to let to match expression. So we'll do an equals here, and I think we also need the lock and the body. The body would be the last thing we do, right? So we want to do something like this, very, very close to this, right? Where we run every matcher on its own, right? Hey Ron, how's it going? Slipped! You followed me by accident. No good, Nick also followed. Thank you both. So we'll do patterns are going to be our. We can't really use this code as it is because we don't have a list of things anymore. Now we have like trees and stuff, right? But we can definitely make to expression and just do like log body patterns there, and then we'll do let rec to expression log body patterns. Sorry, body is not body. Body is data. That's the input, right, to the pattern. So actually, let's get rid of that for a second. We'll do patterns, right? And this will be T really. And it should not be a list of things. It should be a prefix tree. So we'll have a prefix, right? And then we'll have some ops. And then we'll have another prefix tree to run, right? So first of all, we want to translate those operations straight into, right, a tree. And thankfully, we have a module to do just that because we were doing it before, right? So this one over here, if you go to pattern matcher into expression, then we can run that. So pattern matcher, right, to expression, right? And then this actually takes a list of operations, and it takes the body, which is the thing we're going to be doing next. So it sounds like first we will need to recurse. I think. So this will be the case, right? And this will return an expression. Now, when we do try run, which we'll eventually will, right? So I don't expect this to generate the right code at first, but I want to generate some code, and then we can tweak it, right? So then here we'll have some ops, and then we'll have an expression, the final expression, right? And I think we might not even need the data at all here. So we can, I think, we'll see. We want to do essentially the same thing, pattern matcher to expression, but the body is going to be that. So I would expect this to just lay out all the code directly, right? Just know what we want, but it's okay. What don't you like? By pattern, line 890. You don't like this? Why? Oh. Right. So for every one of the operations we want to run, we actually want to put the try catch there around it, like this, right? So we'll do list fun, map, right? Or fold actually. So that is what we will run. And then our base case is actually going to be the exception, right, that we throw. Okay, so that compiled, perfect. We haven't broken anything yet, but that's okay. We are not really using this code yet, right? So now we can go back to the tests and add another suite, right? Yet another suite for the final compiled version, right? And this will be byte stream matching tests with prefix matching tests. And we can probably, I think it's fine. We can come here. We can get rid of all the code or just leave the little unit at the end, right? I think we also want to get rid of these tests. Anything that has a single match, we don't really care about. We will like leave one or two, but yeah, like that. And we want an empty one for sure. Cool. So now instead of doing to pattern match, we'll do to prefix match, right? And when we do that, wait, no, what? Oh yeah, to match expression. And here we actually have data. And that will be the data that you're passing in, and we're just going to call it data, right, for now. And match expression actually takes a list of stuffs. So we will get some patterns, right? We want to grab the patterns. Yeah. So we won't take, okay, so this is the wrong one to use as the base. We're going to use the last one we made. So this one. When you, something like this, right? Where we get the bunch of patterns and then we build the right thing. But instead of doing the prefix match, we'll do to match expression. And now this thing requires also a line, so we'll do log there, and requires data. And data is going to be just data. Cool. Cool. We can, however, borrow this version of the printing. That is based on the actual AST. And I am actually going to borrow the tests that we just used, because these ones are not working very well. Cool, just removing all of the assertions. Cool. All right. And here, every time we see an empty list, we're gonna actually make an empty expression. No, what did I do? Just destroy the file. Nice. So when it's empty, we just assert that it's empty, for sure. And then we'll just pre-fill here all of the things, and then we'll format and play nice and double check things. But my guess, this is starting to look more like what we want. Format, come on, do it. Obviously, it's gonna pass because we have the same thing here, right? And, cool. So let's look at what they do. When we have 3 strings, right, and we have a prefix of on 2 of them, I am already missing one thing here. Did this? Okay, this did it backwards. Fuck. Uh, where's T? T list reverse T. Now that would make more sense, I think. No, you don't want to. Okay, fine. I've tried playing nice with you, but you don't want to format things for me. This is how it goes. Why don't you like this? So, we okay. I think this matcher thing we can get rid of, right? But right now we create an iterator. First thing first, amazing, right? And then we try to read 2 bytes. If we fail to read that, we immediately go into this case, right? Where we just try to read that 10 bytes. So I think we can optimize this by getting rid of that call to the matcher and just doing the thing. You know what I mean? So let matcher, we will just do a matcher there. Case. much more nice, huh? I like this much better, right? So first we start and we do a try, and we will try to read next bits 8 and 2. If this fails, then this will immediately jump out of the try and just go here. We will try to read 10 bits, and if we cannot read 10 bits to run the last branch, then we're done. Now, if we do read 8, then we try to read 2, right? And if any of these fail, then we just go to the other branch. But now comes the next sort of decision point, the next significant bit. If we read 3 and fail, then we go to try test body 1, which is this one over here, right? If we don't fail, then we run the DISA body. Cool. So let's now look at the other pattern that we have here below, because that one is much larger. And we'll also just put the last thing here as well. Come on, Vim, obey me. So test 3, really. So here we have up to 127, or up to 1, right, is the first prefix that we have in everything. Up to comp. When we try to read that there, if we can't read that, then we'll go straight into the rest. I'll just run the body. And the body here doesn't really need much, right? But we expect the rest to be there. That's the variable the body is going to be using. And the body could be any expression, really, right? This is just a placeholder. However, if we match these first 2 bits, then one of these 2 branches will apply, which means we read up to 127, which is the next shared prefix, right? And if any of those fails, then we go back and we know we're here, right? So in fact, I don't think this is the right behavior entirely, right? So if any of this fail, we already discarded this case at least, right? Because this case should not match if you have this string, right? Let's say if you have 128 in the actual data, it doesn't match this one, but it also doesn't match this one, right? So maybe when we need to have an end, like assert empty, right, at the very end of everything that we do. So that way, when we go from here and jump and say, oh, we read 126, we don't know what to do, and we end up in this case, right, which should be here, right, we actually do a check. Hey, is the string empty, right? Because if it's not empty, then we'll just jump to the last case, because that's the case that matches everything. Otherwise, we're falling through, and we're sort of allowing larger data to exist there when we don't want it. Like, this is not match on the prefix of. This is match exactly this many bytes, right? Now, if we do pass all of those, then we enter the next decision point, which is the length. And we compute the length there, right? And we just go about our business. Okay, so I like that. Well, let's make that optimization. And I think the easiest way to do that would be actually in the lowering, right? When we do pattern matcher, right, and we finish, the last thing we should do is have an instruction saying, make sure this is the end of the string, right? So we're going to put that there, right there. Actually, yeah. Yeah, just like we do these things, right? In other words, the empty case, I think this should never happen. No, wait. So we want to always assert with an empty, right? Yeah, I think that's fine. Because we can enforce that if the last thing you have is a capture of the entire string, then once you do that and you call the iterator the rest, right? Which we'll have here somewhere, iterator. If you call bind rest, right? Then we expect the iterator to be empty after that. So maybe we don't need to do that here. So maybe we want to do this one level above, right? In the matching lower, here we will create our operations and do things. But if you do have patterns, then we want to end them, right, with an empty iterator at the end. Let's look at that. Match low, right? We have, which one is it? All. All? No, the next one, 8 bits, right? So this is not just saying I want to match an 8 bits. I want to say I want to match 8 bits and that's it. That should be the end of that, right? So we want to do empty data source. So this asserts, right? Inserts an assertion later on that the thing will be done. And I think we're going to have the same issue everywhere here, except when the bypasses. Because the bypass essentially says, hey, I don't care how big this is. I just want to use the whole thing. Cool, we're up to here, and here, and here, and here, and here. And here. I don't know about the next one though. When I say all bytes, we bind the rest, right? So if the last thing we do is bind the rest, then there should be no check. Or rather, this will always pass because you just consumed the rest of the iterator, right? So maybe it's safe to have it there for completion's sake. It will make it easier not to have that extra special case, right, in the compiler. Cool. And now we'll have this beautiful tiny little thing here that we'll be adding everywhere. So if we go back into match, not native, naive. I meant to write naive. Aye. Cool. So we can probably add that everywhere like that. So that would be the first test. It should pass 8 bits. It does not pass. What's the problem here? Oh, we want the body as well, right? So we'll do that, and we'll do expression e body. So that tracks me. We can go back into really empty assert. Where else do we have it? Run out of music. Replay number 5 of the Quake 2 soundtrack starting now. See here? He was there. Oh, sorry. I'm still confused by that. It is always the next one that is printed, not the one that you think it is. And yeah, now we need to add to all the try runs, right? I think it'll be easier to add them by hand. So this is test number 1. Hey, who was that? Thanks for the follow, Yaziz. We want to do an empty, right? Data source. I think that's about that. Cool. So we go into every one of this, right? Which one is it? Number 2? All right, now we're in the code ones. Okay. What the fuck? No, that can't be right. Here. Fine. I don't have the patience I once had. Screw that. You come again. Perfect. So expression. Hello, Andreas. Thanks for the follow. Okay, so somewhere in here, right? And this was match prefix. Fine. Okay, so 4 tests passed there. The first one here. This first test. Ah, that makes perfect sense, right? When we have no what? What? Why do we do that? The default should be that we do an empty check, right? So when we do empty, we do. Are you serious? So the match prefix tests that we have, right, begin with this. And I don't like, okay. Yeah, so this is a pathological case, right? If you say I have 2 cases that are empty, then dun, dun, dun. Makes sense. I think it makes sense for this to fail. The way it was not here, but here. So I think we could maybe right, safeguard our asses by just doing an assert empty, but at least we don't really know what the source is. So this is why this is invalid. It's not a valid state. How the fuck do we get there? So I think we get there because we pass these 2 things, right? And we build that tree, and then eventually we're gonna call to expression here, right? So I think what we really should be doing is just do this, right? If we have a body but we have nothing to run, then we won't run anything. It will be fine, right? That makes more sense. So now our pattern is like, hey, first, okay, this is a pathological case. This should not happen, right? But first, we assert that things are empty, and then we try running your code. If your code fails, we fall back to the next one. And I think we can prevent this earlier on when we read the patterns, right? And if we find that we have more than one pattern that is the same string, right? Then we can say, hey, we found 2 patterns that are the same. No, right? Because like that construction doesn't make any sense. Or rather, it makes perfect sense. It's just not, we don't want to allow it, right? Come on, show me the next. What? if the prefix is empty as well, right? We will just call build body. I don't know what the body needs, but we'll learn about it in a second. We need log and we need data. Bid should be built. Why don't you like that? We should always end patterns with an assert empty. Are we recursing on the last bit? Let's look at the shared representation for that. Empty, empty, empty. So it prefixes nothing. No, I think that this doesn't make sense because this expression will be the one that builds up the entire try. No, maybe it does make sense. We should always, so we get here. Why did we get here? So we're calling pattern matcher, right? To expression. Only when we have operations. If we don't have ops, we don't do jack, right? And this thing recurses. So we will grab the rest and just call to expression rest, right? And then at some point, we end up being empty. I mean, it's not surprising, right? If the last thing we get is not empty or bypass, right? But I think it is. In every one of these cases, we have bypass, we have empty there, empty here, right? Oh. No, so maybe that's allowed. Maybe that's okay. We just return the body. That makes more sense. So it's not allowed in the other case, but it's allowed here because we might have a prefix that does not end with a check for emptiness, right? Cool. Next test. Go away. This one comes back. I really like the way this reads, by the way. It's kind of messy, of course, when I copy paste like that. But after a print, boom. Doesn't look so bad at all. Okay, so let's check. First, 2 empty strings. This is pathological, but works. Second one. We create an iterator over the data, and then we say we need to read 2 bytes. These are the first 2 cases. Perfect. We read 2 bytes. If we fail to read the first one, right, that means we're not going to be in any of these 2 strings, right? What the fuck? Seriously, Beam, come on. There you go. All right. And then we go into our last case. The next bits are going to be 10 because we're going to try to read the world. And if we do, then after that, we assert that it is empty. And if it is not empty, if there's more data, then we'll do no match. That's fine. Now, if we do read the first 8 and 2, then we try to read the next significant set of bits, which is 3 for other, and then we say this should be empty, right? And this effectively fixes the bug we had, where if we didn't match on this one, we will go all the way to this case, right? Which makes no sense for us to run. And then if we cannot read this byte, then we'll check if we are empty for this one. If we're empty there, then we run that code. Beautiful. So now we have a big case here, right? And we have a prefix of fin1 and 2 for the first set of things we want to do, right? If we don't manage to get the first bit, then we jump straight out into the rest, where we just bind the data source, right, to the rest. And know that data source here, it is not this iterator, it is the source of the iterator. So we need to wrap this still in a function that will provide a value called this. And now we go. Bytes 1 and 2 have been read. They're available lexically for any of these things to run, which is super nice. And then we have 0, 1, 0, 27. We try to read these things, right? And this is where we had the bug a moment ago. If we fail to read this one, right, then this try, right? Sorry, this try is matched by this code. And this would run this body, which is this one. And we don't want that because the fact that we have 126 here instead of 127 does not mean that this pattern has matched. So the first thing we do is to say, we're going to assert that we are done. If this is empty, then we're good. Now, if that works, right, then we can keep reading. And we'll try to read the next significant bit, which is this one over here, right? And if that doesn't work, then we will jump to here. And it will be this one. So note that 127 is the common prefix of both. So we will, if it's empty, then we'll run that code. Else we'll continue running and just, we might not have a match, that's okay. And then once we're done matching the rest, it should be safe for us to call assert empty on that. Oh, yes! We has done it, chat. I'm excited. So I'm going to come here and we still have one more test that I want to go through, but I think this one won't fit on screen now, but this one does. Copy that. Going straight to the Twitters. Oh, nice. It's poor name. Can I suggest Purdy? Purdy. And then we can do sparkles, which is kind of nice. Up early, always. Cool. And with what's his username? We got someone that was teasing me about it not being very smart. And they were right, so I got nerd sniped into optimizing that. Because this is what it used to be before, right? Note how it's so much less code now, right? It even fits on the same screen. Frederick, Warrensburg. Cool. And byte string has a better optimizing a prefix. I don't know what to call it. Prefix matching that only reads prefixes once for any number of patterns. Rocket, you can blame, thank Warrensburg for nerd sniping me. Sniping? Nerd snipping. Nerd sniping, what, 1P or 2Ps? Me into this. Grimace. And we just got byte strings with optimized. Camel sure is neat. Camel sparkles. Whew. Side note, way too easy to nerd snipe me to this shit. Okay, so let's see what else is failing here. Right, we don't actually have an insert empty. Right, we want it to be on the iterator. God damn it. By string ML. Ether. Oh yes, by pattern is not using that. 849. We did not need this. I thought we would, but we did not. So now we can go into our by pattern, right? And everywhere we did assert empty, which is there, we'll just do ether expect empty. And that should fail a bunch of tests, but it's fine. We can go into the test and just do assert empty, right? And replace that with ether expect empty. And that should pass. Perfect. So if we run again, oh, everything's passing. It's a beautiful. Yeah, so, ooh, that's a bunch of code we wrote. Oh, sorry, these are the expectations. Never mind, we didn't write that much code. It's funny because like the byte string module is gonna be like some lines of code, but the pattern one, oh my god, that's gonna be just insane. It's already like 10 times the size. Not saying that's a good thing, but doing format, commit, feed, optimized, prefix matching. Cool. So the last thing we want to do is to actually wrap this thing in a function where we make this data source available so that all of this try catch stuff. Actually, it would be fine for it to be a try catch like that, right? It will be lexically scoping. So variables inside a try are not going to escape the try for some reason, right? So I guess the question would be, should we compare the assembly this generates, right? versus a function, and see if there's anything the compiler is doing there that, to help. No, you know what? I'm gonna by pattern. I'm gonna wrap it in a function. We're gonna do expression, and we'll do fun, and this will be source data, right, or data source, right? So we can put that there, and we can call this function. With the data. That way, we can get rid of the data there, and we are missing one of those. Cool. And just follow the types. So to expression, right? Are we even using the data? We're just passing it around. Not really. Boom. So that will fail a bunch of tests. Okay, I'm not sure how I like that though. I think it's fine. If you call the function, right? With non-empty data, and it immediately, and if you get it, and you expect empty data, then it better be empty, right? I think that's wrong. I think this is wrong. We want to be able to say, I expect the data to be empty. If it is empty, then do this. If it is not empty, no, wait, that's what this is doing. Expect empty, we not throw if it is empty. So then we try the body, right? And the body right now is just doing this weird thing, like the pathological case. Okay, cool. So we can now update our tests again. I don't know. Is it a pain in the ass to update a test like this? Yeah. Is it like a blocker? No, not at all. Cool. Hey, Simbleed. Let's see. What do you think about companies extending the start date of internship by 3 months due to visa? I hear you. I feel you. I'm an immigrant myself. I've had to deal with like visas being rejected, visas being sort of delayed, uh, that sort of thing before. I've been an immigrant in quite a few countries right now. I'm from Argentina, and I was an immigrant in Chile, which is like immigrant light. It's pretty easy for us to go in there and come back. Also in Ireland, in Denmark, in Germany, and in Sweden, where I'm currently at. For companies, it's complicated, right? Because they have some needs, and the needs go beyond the. It sucks. It always sucks. Like I'm with you on that. It always sucks. But from the side of the company, sometimes their hands are tied to some things, right? And they can't really say like, oh well, we'll extend it or not extend it. And those things could be financial years, right? Like closing of the year and might require some budget thing to be adjusted, right? Or some budget to be spent before the end of the year. And it sucks because all of a sudden you as a human, right, that are going through a very traumatic change, which is moving somewhere, right, and working somewhere and or studying somewhere, are put in the middle of that machine, right, and then you you suffer because of that, or at least I have in the past. Yeah, it sucks. I'm sorry to hear if the case is that your visa got rejected or you can't really get there. But sometimes the best candidate, from the company's perspective, right, is the one that's easiest to get up and running, right? And that might mean, hey, you know, we can't sponsor visas. I know a lot of companies don't do that, especially in countries like the U.S. Which I've worked for a lot of companies in the U.S., but I haven't lived there, so I don't know what it's like to be an immigrant there. Sorry, I don't have a good answer to what you're trying to ask, I think, but hopefully that helped. Cool. So that I think that's the end of that part, right? We did the Pata Magic compiler. I'm gonna share. This with Felipe. Who's been working on the implementation of the byte string representation. So this is the thing that the syntax we just worked on, right, will actually end up calling. Like when we see all of these compile calls, right, to byte string iteration, right, and so on, that is the stuff that Felipe is helping with. And we're building all of this for Riot. And Riot is an ocaml multi-core scheduler, which means it lets you write Erlang style programs in ocaml or elixir style programs in ocaml. And I had built a very crappy, a very, very crappy buffer that is mutable, and it just became problematic. So we're rewriting the byte strings, right, to replace this buffer and to be able to have, by default, right, efficient, pattern matchable, immutable, right, binary strings and bit strings that we can use for networking, for parsing, for just regular data, right, throughout the entire sort of Riot runtime, but also on the applications that run on Riot. So if you build an app that runs from Riot, then I'm hoping that soon enough we'll have other layers on top of it available, right, to make it easy to do that. Then you will be able to use this string, right, that will be crazy fast, crazy nice to use, right? Yeah. Excited about it. Okay, we'll review a PR here. Cool, we have a PR from Diogo. And this PR was really good. It's about making sure the program, the entire application, right, terminates if the main process terminates. Because right now we have the case where if the main process raises an exception, right, so terminates abruptly, then we will terminate, right? Hey, Jesse and Barry's, or Jesse and Barry's. How's it going? All good? And we want to be able to say, okay, if the main process of the application finishes, then we will shut down the application, right? And we did this quite nicely here by checking for termination. And now that I think of it, like when I now that I say all that out loud, I think there's another place where we can move this code. This PR is perfect, so I love it, right? It even has a nice termination test that we can check, right? If the runtime does not terminate after the main function terminates, then this test will hang, right? All good, all good. Just hacking on ocaml, writing some ocaml code. Because now I'm thinking, we'll merge this. I think this is perfect. We'll merge it. And I think there's an optimization that we can do. So squash and merge, feet. Awesome, Diogo. Thanks for the contribution. And actually, looking forward to that next PR. I'll think about that on my next PR. Ooh, Elixir is fantastic. I've written my fair share of Erlang and Elixir in the last decade. And in fact, the thing that we were doing today for ocaml is to be able to write pattern matching on strings, right? Like you do on Elixir, but on ocaml. Because right now that's not possible, right? So we wrote this extension to the language. If I do a test here, that lets us write matches like this, which is not that different how you do it in Elixir. In Elixir, you may have seen the binary string syntax, like hello, like this, right? Where you can also destructure, so you can say, oh, on the left side of an equality check, right, I'm going to have a big string like hello world. Oh, watch out, there's my cat here. What's up, Leia? All good? You want to be on stream? And in this case, this will fail because we don't have exactly hello on the right. But we can say, I'm going to grab hello, and then I just want to like get the rest and ignore it, right? And in Elixir, you can do that. Rust is also awesome. I've written also my fair share of Rust. I started a company last year, right? Yeah, last year. The year before that, really. A startup where we built almost everything in Rust. It was a build system, so a lot of low-level stuff and so on. It's amazing as a language. It has its, let's say less nice parts, like every language does. But overall, I think it's a net positive. Learning it will make you grow as an engineer, as a developer. So do it. Both of them, really. Even though they're very different languages. What do you want? You just want cuddles, right? This is Leia, by the way. Okay. Off we go. stay here. So you can sit there. That's stuff, right? Oh, you did. Nice. What was their name? What was it called? What were they called? Akira. Nice. Okay. So the nice thing is that now we can expand it. We can grab this thing, right? Which is the old version, which I think we have committed to source. And if we do describe pp, right, we can put that back there, and then we can do a diff. Mm, this doesn't look right. Oh, right. PPX. We didn't update this code. Okay. That makes perfect sense. Aye, aye, aye. So we just want to save here the byte pattern and the body, right? And then we can call uh, byte pattern layout, stop kicking, to match expression, right? With the lock and the data. And the last thing we need here, right, is the list of the cases. So cases. So when we do that and we call this thing again, then the diff should be mostly removing code. That's a weird. All right, do informant. That makes more sense. So we generate first, and then we do diff. Yeah, look at that. Look at that diff. Yes. We removed all of that stuff, right? We add a little bit at the bottom, but it should be mostly removing things. So not only is it more efficient, it's also less code. This is correctly interpreted as an integer. And if we come here, right, everything should still be integer. Some of these things we probably want to, okay, we can do some work on the types here, right? Because we want these values, right, to have the right type always for inspection, right? Yes, code provides the way, yeah. I code for food, essentially. Oh no. I have used many languages professionally. The last one I've used was ocaml, but I've also written Erlang, Elixir, Rust. I've written Reason ML as well professionally, Rescript. I've written JavaScript, Java, Scala, Python. I've written Ruby. I've written PHP and C as well. Um, I have a baby face, but I've been around. Not so obvious now with a beard, but it probably means I've written CoffeeScript as well. Flash Action Script. Definitely missing some things here, but Visual Basic as well, of course. Yeah, yeah, I think it's a bunch. I know some people that have written a single language their entire life, and they're very happy. In my case, it's like the more languages I learn, the more unhappy I am with all of them. uh, but what languages do you write? Are you a developer? Like, do you develop things for money? Hey, Fixie, this is Leia. It's not my cat. I'm actually just cat sitting for a friend. Same thing. SRE, DevOps, Dev, front ender, back ender. Same thing. Different concerns, different domains, right? A lot of core skills that are shared. A lot of domains that are outside of computing that are not, right? Like if you're a front ender, you definitely want to know some things about color theory, for example, right? To understand, like, hey, just what I look good, right? If you're building backend stuff, distributed systems, then maybe a lot of things there you could learn and probably want to learn, like consensus, right? Consensus protocols. Then as a front ender, maybe you don't need to understand to build the stuff. So the domains of distributed computing are different from like user interface, right? Building. Hey Sabine, how's it going? Yo, you should go immediately follow Sabine. I don't know if Sabine's going to be streaming today, but she's doing an amazing work at keeping the OCaml community friendly, welcoming, right? Having great documentation, making sure that documentation packages are being built correctly and stuff like that. Really, God's work. So thank you, Sabine. Yeah, again, like system kernel stuff, there are some things that you need to know there, right? That are domain specific, and some things that are just general good programming, right? Like I've had to do some low level, like let's say, uh, dynamically patching libc for tracing things in Rust, right? And I've also written web apps, right? And it's not say it's not hard. It's incredibly hard to do either of those things really well, right? But there's a massive overlap, right? Or rather, you can make the overlap really big, right? There's a lot of things you can learn from one domain and apply to the other. Off you go. Sabine, that makes a lot of sense. I don't know how later will be later, but we may raid you if you're, you know, if you start and we're here. Aw, thank you so much. Yeah, I'm just like in the whole rabbit hole thing right now. We got the most of the syntax up and running right now, and once we do that, Felipe is helping build. I mean, he's building the entire representation. Once that's done, then we can put that together into Riot, fix that, and then keep fixing the layers above. And I think that will help make the last 11, 12 tests of Nomad. Yeah, exactly. Jack shaving at his best. I don't mind. I think some of this work needs to be done. It's just a matter of sitting down and doing it, right? So as long as I have the energy, I'll just sit down and do it. And you also hear on the stream, like a lot of the testing we're doing for this thing is like pretty boring, pretty like repetitive stuff. It's like, it's okay. It is almost meditative, right? I don't need every piece of code to be like a mind-bending puzzle. If I wanted to do that, I'll probably write Haskell. And it would be true for me because I'm not that smart. I look at Haskell code and I'm like, I need to think a lot. We were talking earlier, Sabine, about actually what would be the path to get this up and running, make it run nicely on Riot, and submit a patch to ocaml. And say like, hey, this is the thing we want to build into the compiler, right? Pattern matching on strings right now, when you do match on a string, it's pretty limited. And many people recur to splitting strings, right? To get the head, or using substrings to get like the head of this thing or that thing. So like this code you have on screen right now being all generated from the match specification, right? That's the way you would normally, if you wanted to do like very, very fast string matching today, you would do it. But this is a pain in the ass, right? So birdie. Okay. So we have a couple of bugs already here that we want to deal with. But off the top of my head, like the least I would do is just try to have the same pattern twice, right? And this should be the same as having a single pattern. I also would like to support guards because right now we are not passing in the guard, right? But that should be straightforward because we have the guard here, right? Like guard, case, guard, right? So we can pass the guard and the body. And then when we get to match expression, right? And we do prefix match, we will have a guard here. So we can just pass in the guard. Actually, we can simplify this a lot. So if we wrap the body in a guard, right? So essentially the guard will be something like this, right? You have an expression where we say, if guard, right? Then body. Else, we will raise. byte string no match. And I think we do that, as dumb as it sounds, right? This will make sure that if you specify a guard, actually we probably want to do this with a match here, like match guard with some guard, right? Else, just a body. If you have a guard, this will be none. What? Log or log, two prefix matches. Do we want to do that though? Yeah, I think will be the easiest thing to do. Just passing the current location. Because then we just treat the body as its own thing. Yeah, essentially we want to like grab this thing and do like when the payload, right? Empty. Something like that, right? And then if we go into the expanded version, so this is a dumb guard. If we did something else, right, when my guard, right? Yeah, that sounds reasonable to me, right? We check for all the things. If we get to the point where we should be running the body, if there's a guard, then we'll run it. If there is no guard, we won't, right? And if there is a guard and the guard returns false, then we will just raise that there is no match. And the no match here assures that we go one level up, right? But every one of these things. Wait. Because if we throw here, right, we're this try catch. So we end up here. And then we'll check if it's empty. Again. Right? But this is not what we want. Because at this point, this iterator, right, has already gone through all of these things. So maybe guards are more difficult, or there's something more about them. In fact, I would expect this code to run perfectly fine, right? Because the data source will be empty because we already went through the whole thing. I really do want to fuck with the ocaml, and you keep making me want more. But I also have a job, love seeing live music, and need to plan a wedding. I don't know. I don't know what to say. How do you get so into this? Like, just sit down and do it. Just do it. Yeah. I mean, of course, if you have other priorities and you have other shit you want to do, then go ahead and do that, right? That's fine. Like, I would not put ocaml over planning a wedding. Nobody's wedding. Like, it's too important a day, right, to fuck up, I think. But then again, I'm not married, so maybe no. I don't know. Point is, Vox Populi says this is very important. So, but right now I'm not planning a wedding, so I can do this. So how do we deal with this? We're gonna do the sixth round of the Quake 2 soundtrack. I love it. It is definitely not as good as, like, objectively, right? It just has a couple of good moments, but most of my childhood was playing Quake 2. So it is also a good soundtrack to kick some ass. So all right, hear me out, chat. What if we keep track, right, of what is read from the iterator? Hey, Jesse and Barry's, like, if you use Docker, Docker has tons of ocaml in it. What if we keep track of the iterator, right? So that ocaml is one of those languages like Erlang, right? Elixir people hear more about these days, but Erlang has long been a secret weapon, right, of a lot of companies that they build on Erlang because usually people get incredibly productive in Erlang. Like, once the kind of people that really like Erlang are just insanely productive in Erlang, right? So just like WhatsApp was able to serve, I don't know, billions of requests with, like, I don't know, 4 people, 8 people, 12 people in the team back in the day. There's a lot of, just like that, there's a lot of ocaml in very, like, critical places. For example, you say you want to learn Rust. The original version of Rust was written in ocaml, right? The first prototype that they did. ocaml is amazing for doing languages, compilers, developer tooling of any kind. There's been a lot of work into making it a great language for doing networking, right? So there's a couple of interesting pieces of tech that are being reused in applications like Docker. Yeah, small team, many users. Definitely. If you have a small team and you got to do a lot, go for that. If you can get 1,000 programmers, like, running or building something, then maybe use something else, right? It's a lot of programmers. But if you can only do, like, 4 people, it's not perfect, right? Just like Erlang. It's a very DIY community where there's a lot of things missing and you have to build them yourself, right? But there there is a lot of, let's say, teaching, right, in these spaces where people just encourage each other to build the things they need rather than to wait for somebody else to build them and then reuse, which is normally what you see happen, like, in the JavaScript or Python ecosystem. A lot of people go like, "Oh, that doesn't exist." Okay, it's on npm, it's a PyPy. No, it's not. All right, no worries, right? So then one day you wake up and then you can build everything. There's, like, absolutely nothing that you can't build. Not because you think you can build everything, just because, like, the problems arise and you just sit down and fix them. Um, it is kind of amazing, and it's very encouraging. As a still learning engineer myself, right? I find that ocaml has taught me that, you know, I can go deeper than I thought I would be able to. It became very philosophical as an answer. Yeah. Anyways, hopefully that gives you some idea. But Sabine, do you want to add anything? I know you have a lot of thoughts in this space as well. Yeah, DIY communities definitely have a lot of expertise. 100%. I think RFCs and stuff like that is good. It takes a certain kind of mind. I'm more building driven than will understand the entire spec before I sit down. Just not say that that's how other people do it, but just not really my thing. Um, so looking at how other people are doing things, learning from that, and then building. Good space to do that in ocaml as well. So if we keep track of how much we have expected to be there, no, I think if we are inside of a pattern, right, we can throw a guard error, and that guard error or guard mismatch, right, should only be picked up by other people that are at the same level as you are, right? So people that have read exactly the same amount of that byte string, right? So let me try that for a second. We don't really have a byte error yet, but a guard error, but we'll do that. Guard mismatch. So now that's a guard mismatch, right? And this guard mismatch would make sense to pass if we had another branch just like this, right? That does not have a guard. So my guess is that when we compile this, it will become a try around this stuff, right? With byte string, right? No match, etc. So again, pretty print, format. There you go. That makes more sense, right? If we don't have anything else, then guard mismatch is not going to be caught, and that is something we can just raise all the way up, right? What are you doing, Leia? I don't want you tapping on the screen. Okay, you can walk around. However, if we are at the same level, if the run has no ops, is at the same level, right? And has a guard, then we do want to add, right, byte string guard mismatch. Because then the guard is going to disambiguate between these two different tasks, right? Like the first one and that has a guard called my guard, and the one that does not. What are you doing? You want to be scratched? I'll scratch you. More? I haven't confirmed this, but I get the impression that cats like to be scratched where it's hard for them to scratch themselves. That's it. Like the only reason that they want to be scratched like on the head on top there is like scratching there. It's really hard for them. I haven't confirmed this, but that's my impression from observing Leia. Anywhere else is like no, don't give a shit. Just scratch right there, or like in the nose, for example, that sort of thing. Oh, light mode. Okay. Okay, I'm gonna mute for a second so I can eat a cookie. Because I read recently somebody commented on a video that I recorded like 4 years ago. Actually, we're gonna go there. Reasonable coding C++ actors. I forget exactly what the video is. CAF. That was it. YouTube. CAF. And of course, I'm never gonna make it here. I have terrible SEO. But YouTube, if we go to the channel, there was a video somewhere here. 4 years ago. 4 years ago. The video, native actors with CAF. Right? I'm going to open that, but we're not going to listen to it. Also, long stream. This was a live stream, by the way. And it was a lot of fun to go through this stuff and so on. And then recently someone was like, please don't chew peanuts when you're being recorded. It's like, well, I didn't know better. I didn't even realize I was eating peanuts. Yeah, Jesse, that makes a lot of sense. And I imagine that also, the parents, the mother of the cat, right? Probably does that also out of instinct, right? Like it's a learned behavior and I guess inherited behavior. I don't know, honestly. This is not my field. Developer.com. I kind of want to go there. Nope. Dedicated my brain. Okay, so this is for developer influencers. I'm sorry, I'm not an influencer. I write code. I'm an engineer. I build shit. Okay. So, how do we do that? How do we make this happen, right? We could, by default, always add a guard mismatch, right? Everywhere, which will make things a little messy. So maybe we want to preserve the information that there is a guard, right? Until the very end. And at the very end, we know that we have a guard. So when we do the try catch, right, we have a try expression here. Here, right? We get a case back. We will get a case, but also we would get something that tells us, hey, we need a width. We need a catch here, right, for the thingy. You get what I mean. You're smart. You got it. All right. So, where are we? Body. We're just going to add the guard to this thing. So we'll do the same thing as this thing, right? But it will be an option. And then we'll have a guard here. So the guard itself is just going to be a match and guard, right? If we get a none, then we'll just say none, right? If we get a sum, then we will say sum, right? And then we'll append the same thing here, but for the guard. Cool, so that fixes that. This is it, this is the one. So we'll have guard 1 and guard 2, and we will preserve these guards throughout, right? The closest to the body as possible. Actually, I think it would be even better if we make the body, right, and the guard a tuple. So instead of having this like that, we'll actually have this. And when we need to, we can pattern match that and just see both, right? But then most of the code that doesn't care about the distinction between the body and the guard doesn't have to. Guard, body. So if we do have a guard, then we will add our good old expression, right? If guard, then we run that, right? The body. Else we will raise byte string, right? Guard mismatch. And that should be a single thing. But we probably want to return the guard as well. Like that. We make a body. If we have a guard, then we'll actually wrap that in a guard, right? And then we return that. Perfect. No, that's fine. What? You forgot already? That sucks. Line 900. When we do build body, we get or guard our body, right? Like that. Yo, Pixel Hero! How's it going? Oh, so the big picture, the really big picture is that I want to help make ocaml SaaS ready. I want it to be as ready as Go and ready as Elixir for you to just bring it at work and say like, hey, we want to build something in ocaml, and people will be like, cool, no problem whatsoever, right? And to do that, I am banking on a couple of things. I think people agree with the mission. They might disagree with like the sort of beliefs I have, right? To get to that mission. But one of those things is that we need free multicore or multicore as easy as possible, right? We need to get rid of literally most of the types, which is a weird thing to say in a type language, right? Windows support, not just yet, but soon, eventually. So we need to be able to build things that are intuitive, right, for the developers, easy to sort of get started with, right? So some of the things I've been building have a crazy amount of focus on usability, on examples, so people just pick them up and can just start using them, right? Which I think should be there always. If that's not there, it doesn't really matter how amazing something is. People are never going to realize how amazing it is, right? And we need to help people get there fast. So this is like the super big picture, right, on what I'm trying to do here. There's a couple of things that are more moving behind that. But it all starts with the Riot project, which is an ocaml multicore scheduler, right? For building things in the spirit of Erlang and Elixir, so that kind of concurrency. And on top of this, we have built a socket pool, right? That right now we're trying to build a web server on top of called Nomad. And Nomad is getting very close to HTTP 1.1 compliance. We have a lot of things checked here, as you can see. This still needs some updating. And once this thing is in place, right, then we will be able to start building layers on top, because we would have good base infrastructure, right, for building applications that are entirely multi-core, right, without even trying to be multi-core, right. You can do these things in ocaml right now with other things. We can use frameworks like Piaf or Dream and EIR, right? But if you really want to use all of your cores, then you have to sort of change the mindset and say, I'm going to manage these threads myself. I'm going to actually work, right, one level below, right, to orchestrate the workload across many cores. And that's one thing that Elixir and Go don't have. You don't think about that at all in either of those. I would say a framework would be a good name. I think platform will also be good. It's like specifically Nomad and Atacama, I'm not that attached to it. I think these are just like means to a goal, right? Even Riot, right? If we can come up with a better way of doing multi-core, right, for free, by all means. My belief is that the actor model, the way of building apps in Erlang and Elixir, is the way to go. Runtime. Runtime is a good name as well. So yeah, those are sort of the foundation pieces. There's other stuff that I haven't talked much about yet. I think Dune merging with OPAM or Dune PAM being absorbed would be fucking amazing. I would love to see that happen. Hey Nix, I see your app as well. We have been listening to the Quake 2 soundtrack on repeat. This is the 6th time we're listening to it. You arrive at a great time. We're adding support for guards, right, to our binary pattern matching. "7 a.m. You couldn't join then." I don't know, man. Sounds like a skill issue. Just keep me on your phone in mute. Raw and cooked. What's the context? Terminal mode. Rare. cooked. Ah, this is new to me. Cook mode. That's so funny. Minty, by the way, reads in raw mode. Jesse, I understand. I get it. It makes sense that I'm just dropping this thing, and you're like, "Well, I don't really know like what's happening," or like that seems so far away. I think it is far away. It's not as far as people think, but it is far. It's getting closer every day. Every day we've been doing a lot of work to get there. There's a couple of things that soon are going to start taking more shape. So right now I'm focusing very, very aggressively on a vertical slice, right? We got the basic runtime scheduler. It works. It does a few things. Amazing. We got the socket pool. We got the web server, right? By building the web server, we've also been building this sort of middleware layer, right? That eventually will essentially give you the same experience you get in Elixir with Plug. Which, if you're looking to learn Elixir, you probably looked into Plug as well. I wish it had a proper website where this is very low level. You never do that. You usually work with this abstraction, right? And once we have something like this up and running, then we can build better abstractions on top, right? But already having things like, going back here, Riot and Atacama means we can start building clients, right, for reading out of websites. So, for example, something like Blink. Oops. And this is something we prototyped here on stream. And it's not the solution, but it's a very small Elixir inspired as well HTTP client that works well in the environment where you have thousands of processes running, right? So with these things, you can build, for example, scrapers. If you want to build a scraping framework, you can do that. If you want to build like background jobs frameworks, you can do that, right? And yeah, eventually we'll look at something like Laravel. Right? And we'll have an ecosystem like this. We might not have an ORM, but yeah, all of the crap that you normally want to have already there, right? Just want to make sure that we're building on a foundation that, will do fine. Seriously though, Laravel is amazing. It has so much stuff. I can't wait till we open a PR, right? At an issue to some framework on top of the stack, right? And we go like, all right, folks, let's start porting all of the crap that Laravel has, right? We don't need to be smart here. We don't need to be creative and unique. We just need to make sure we have an ORM, right? We need to make sure that we have actual migration support management that does not suck, right? All these tiny things. I know it will be so much hype. I will be so excited. Max width. There. Does that paint a good picture of the future of the top of the mountain, Jesse? We need to change this to something else. Yeah. There you go. I wonder if we can quickly change the orange teal. Yeah, red. Yeah, we can do that. We can go into. I think I have that color in Practical Ocaml somewhere. Nice. Yeah, here. We're gonna grab that ghost accent color, which is this. I come here. We're gonna just drop that red there. Oh, that looks not so nice, but where else are we defining that color? Search. Primary color. This is a bad idea to replace everything like that. Come on, you have to have the color somewhere, right? Oh, is that there? No way. Text red 500. Ah, thank you. So I guess we'll just add a color to it. Color. Ooh, I don't really like it though. I think it's a little too. Could be brighter. You know what I mean? Anyways, so. Soon in an OPAM near you. It's also funny because I think Tej was saying that they love Laravel, and I offered to write an OCaml to PHP backend. Oh yeah, sorry, chat. Here you go. Go bananas, go bananas. Share, like, subscribe, retweet, all the things. Anyways, yeah, this is what we want, right? We want to have that, right? And we want the right amount of type safety, right? So we don't need everything, every fucking thing to be typed to the point that you make one renaming, right? And then you have to spend a week just working through it. ReHP? Oh yeah, ReHP, yeah. I remember that. She posting like crazy. But yeah, I might as well share this with you. I've been building this thing called Trail, right? And it is pretty small, but it's essentially plug. And it has a couple of nice things that we can mostly see in the tests, right? That I've been writing for Nomad. Because Trail is actually below Nomad. It's like Leandro Dynamic Arc. I've had that arc already, man. Like, I wrote a lot of Ruby back in the day, and PHP as well, and Python, and JavaScript, and Erlang. I think I've been mostly writing dynamic languages most of my career. Oh, we got a follow. Hey, Mateos. Gracias por el follow. Yeah, so the thing with Trail, right, is that this is something I hate as well. We ranted about this earlier, about how prone the OCaml syntax, right, is to dense code that is just really hard to parse, right? This is Trail, right? It gives you a connection module, right? Has handlers from connection to connection, and it has utilities in there for like sending responses, sending files, doing all these sort of things. Hola Mateo, sí, soy argentino. ¿De dónde sos vos? ¿De qué parte? ¿Hablas español? Pregunta Chango. And we can do some cool things like do connection upgrades right here, right? So in the WebSocket test that we have here, web test. Where the hell is the test? Autobahn server, right? There you go. So we set up a trail, right? With a logger and then our echo handler. And here we're just saying like, all right, we're gonna create this module, right? As a sock. And a sock is something that can handle connections in sockets. And then you say upgrade, right? So whatever connection comes in, we upgrade to that socket. And that means we can now handle our WebSocket in this tiny module, right? And it's its own tiny process and so on. Ah, soy de San Juan, Chango. Yo soy Tucumán. De Tucumán. Estamos haciendo ocaml acá. We're writing some ocaml. But yeah, I don't want to focus too much right now on these higher layers if I don't get the lower layers right. So the highest I'm willing to go is the web server. If that works fine, right? And we're very close to full compliance with HTTP1. I mean, full, I'd say, as per the Bandit test suite, right? Then we can do some work to make sure that it is also fast, right? And we don't need it to be the fastest thing in the planet. We just need it to be fast enough, right? So it's fine if we are like, I don't know, half as fast as Dream, for example, or PHP, because we're just getting started, right? We first need to make sure that whatever we're doing, it's actually correct. Because if it is correct, there's enough declarativeness in this layering, right? That we can optimize everything under the hood without you having to change your applications at all, right? So much cat hair here. Yeah, so that's what we're up to. And we were here trying to get the body out of this thing, and we do now have a guard. So I don't think this will work. Because at the deepest level, right, we know we have a guard, right? So we could try catch ourselves with that guard. But the outer layer, right? So if you go back here, right? We don't want a guard here. Right? We only want a guard if we have one, and the next thing that we need to run has the same pattern. Wondering how we're going to do that. Yes, right now we're adding guards to the by-string compiler. So without guards, it works fine, like that. You capture fin, fin's an integer. You capture the payload, right, using the length. The length is an integer, right? And the payload is a byte string. And this runs beautifully. And this is sort of the generated code from that, which is also doing the least amount of reads it can, right, to do the routing. So we only read on prefixes, right, and so on. And if we fail to read the prefix, then if we have a fallback case, then we go there, else we just blow up. But we need the guards, right, to be able to implement some of the cases, right? Oh yeah, I have an article of that. Practical ocaml. I'm amazed that people are like, this is the preferred way of dealing with this kind of parsing in ocaml right now, right? You define your buffers, you define your mutable strings, and then you go over the strings and try to do like the work there, right? Maybe use something like angstrom, right? And then you use it, and you have to sort of use the buffered or unbuffered angstrom parsers for this, right? And then this is the bit string package, which is an existing version of something like this, but that I find very unergonomic, and it has some weird implementation with its own type of string, right? That you can't do much with. And I don't want to contribute because it's GPL, so I figured, okay, we'll make one that we like, and we'll make it very tight with Riot, right? And we'll make it purely immutable, right? And we got Felipe working on the byte string implementation under the hood, which is going to slap here. It's going to be amazing. This is a rope or a chord based string representation. It's going to be super amazing. Super. Anyways, so this, so much better than all of this code, right? So much better. There you go. This is declarative. This is what I want. I want this and that and the other thing. The compiler figures out how to do it. So the last feature we need from something like this to be able to work, to sort of port this, is to support this guards, right? So this just gave me an idea. What if, right, at every shared prefix level, or when the shared prefix is empty, right? So essentially prefix here, for example, right? When the prefix is empty, we introduce an exception, right? That is local to that scope. Because there, at that level, we know that. No, wait. When the try runs are empty. When the try runs are empty, that means you share your prefix entirely with something else, right? I think I need to visualize the this. Because the current tests I have are if you have a bunch of patterns, right? And they're the same. Then we would want to, like, if we duplicate this, right? And we run that test. What don't you like? 915, fold left. All right. Cool. So I think that should almost do the trick. 746. Now we have no bodies there. Perfect. Actual. Right. The downside is that now we actually need to pass in the lock. You serious? Seven, 6, 7. Oh, right. It's gonna be easier to just let the test tell me what to do. The printer is broken, so let's fix the printer. So this should be like that, and this should be small s, and this should be an ID there. So it would be easier to copy paste. Cool. So if we go back, cool. So we can replace that. So now we can go back to our last case, right? And here we see what happens. If we don't have a guard, right, we can probably remove this stuff for now. Or maybe even make a separate case, right, that includes everything. But this will be for the duplicated case. And we'll just add a separate there. Cool. And we want the expression empty, so we'll just get a dummy expression going. Perfect. Cool. So what this compiles to, right, is all the checks, right, as fast as we can make them. Great. Amazing stuff. Good. And then we try to run your code. But this is not really what we care about. It's like we don't have guards here, right? So we're going to add a new parameter here called guard, right? And then here we'll just add expression false, right? Or run guard. So to our test up there, when we define it, we'll pass in a guard, right? And this is just going to be an option. So we'll just put the guard straight here, right? And now that should compile, I think 1092, like that. Cool. So I believe that now we have the guard in the absolute wrong place, but so what I want to see here is I want to see, oh, if run guard, right, then we're going to do that thing. Else, right, because we have the same prefix but different guards. Else, actually, I think it would make sense to just try to do this. If the guard runs, then we'll do that. Else, we'll do test3 body 1. Like that. I think that is what we really want, right? I'm gonna probably want to move the guard into the pattern itself. I don't know. So in this case, everything has a guard, right? And this is the only thing that got it. But like, I believe the dumbest thing we could do would be to say, okay, if a series of branches, right, they have the same prefix, right, then we will throw this thing. The tricky thing about doing control flow with exceptions is that instead of going downwards, right, or upwards, you sort of jump from here to there and so on. So that works fine for the no matching, because in no matching, essentially, we always want to say, at some point in the execution here, we want to jump to this other place in the code, right? But for the guards, we don't want to do that. So we'll actually do something nasty here for the test. Guard if id x is 0, right? Then guard, else none. So then only one thing will have a guard. Only the first one. Cool. Okay, we have a test case set up. Let's make the changes. And as usual, I think we're at the wrong level of abstraction. Maybe we want to fix this higher here. While we still have the prefix tree, it would be straightforward for us to say there is a guard, so do something with that. Oh, I never muted myself. I thought I did at some point. Yeah. Yeah, okay. I think we can bring that case up, right? We do want to have it here because we will want to test that the code that we generate is what we expect. But I think we want to lift this case up. We can put it here. And I think that will be fine. 2, 3, 4. Yeah. And we can say guard, right? So if let guard equals if index is 0, then guard else none. And then we can pass in the guard there. Because then we will actually see, there you go, better operations. So it is clear from here, right? Obviously, not as clear as I hoped it would be. What are you doing? No. It is clear from here when we do try run, right? And it will be even more obvious when I copy and format this crap over here, right? Doing format. I think something got broken there. Yes, terribly broken. What in the hell? Run card. No, Leia, watch out with the cables and everything. You are choking yourself. Okay, Leia, now. Basta, basta. Meu Deus. Essa gata tá doida. Yeah, so the brown guard here will actually just be ocaml. I'm gonna have to fix this, aren't I? Yeah, okay, let's fix it. Again, the printer is broken. So we do some. There you go. And we want to do ocaml space, right? We're gonna format sprintf, right? That will be so much easier. Cool. So we will build that string correctly there. And now that it's empty, save. It passes. And I believe that this should be syntactically valid ocaml. No, what the fuck? Just paste the thing. Damn it, Vim. What are you doing to me? Are you serious? I'm on insert mode. I press paste. You paste the thing. So here we just want to do ocaml. Cool. So just want to reiterate here. This will be obvious when we print it this way because we will have the two things side by side with 0 operations that are different from each other, right? And that literally means there should be a way for us to go through this list, right? And turn that into an if else. Because if we can do that, that would be amazing, right? And I think we should do that here in this prefix matcher. Or maybe not exactly here, but somewhere before, right? Don't care where or when, as long as it's done in this level of the representation. So before we go into dealing with the actual ocaml ASD, I don't want to touch that. I just want to use it to convert to code at the very last stage, right? I want to use our SAT ASD until then. Hey, Sandrell. What's your name, Blue? Cool. Yeah, typical cat. All right, folks, ready for run number 7? Oof. Just love how it starts. Really gets you in the mood for building things. I'll mute. We're back. So Sabine was rightfully pointing out, right? Because she says like, "Oh, I want this on the ocaml framework for web artisans," and I'm like, "I'm building as fast as I can." That I don't have to do it all by myself. And she's completely right, 100%, right? What I'm trying to do here is I'm not even considering building everything myself, right? I enjoy building stuff, right? But I am very aware that there is a physical limit to the throughput I can have, right? Especially when some things are needed in parallel and so on. And that the more lasting thing here, because everything I create is risk, right? As a coder, you as well. Every line of code you write is a risk in some way, right? So the more lasting thing to do is to build community. And I'm hoping that together we can do some of these things, right? So really what I'm trying to do here is sketch a vertical slice that will set the tone of the work, right? That will say, these are the things we value, right? We value clarity. So we want code to read as fucking dumb as possibly, as possible. So that no one else has to wonder like, oh, wait, I need to learn not just this new library, right? That does this thing that I wanted to do, but I also need to change the way I think to be able to adapt to this pattern that was not needed at all, right? So there's complications in complexity, and there's a lot of complexity already, right? So if we can get rid of the complications, right, unless they're absolutely justified, then I think we should. So clarity is something that I put a lot of work in. Even the fucking, dude, like, come on, they generated code, right, here. You can read through that and be like, okay, if there's a lot of statements that need to be executed and so on, but if I read through it and I evaluate mentally, there's no magic here. It's just like linear code with a couple of try catches that go all the way at the bottom, right? It's always going one level below, right? And so on. So clarity is something that is incredibly important for me because as literally as I grow older, I forget things, right? More and more often. So I want to be able to go back to a piece of code and with just a few tools, mental tools, be able to understand most of the code. That'll be one thing. Simplicity is sort of bundled into that one, right? The second one is the right amount of safety. We don't need everything, right, to have its own opaque abstract type to the point that you cannot add two numbers because number one and number two, they have different types, right? We need to find the sweet spot. This is as many types as we need. Not as a unit of typing, but as a measure of typing, right? And work from there. It's fine to ask people to do some random checks. It is completely okay to be like, oh, you're going to be doing this thing. Check that it is an admin, right? If it's admin, yes, do the thing, right? It's fine. Obviously, there are some cases where we do want the safety because it's important, right? It's justified to have that extra level of safety. But I would not put type safety over, right, the clarity, over the ability to be able to use something, unless it is critical, to get it right. And another thing I like is the ability to change the performance of the applications, right, for you. So I like platform work. I like to be able to say, hey, you're going to be running on top of this thing, right? So your job is to go make your app, go make money, go make your business run, right? I will make sure, right, that this layer gets faster and faster and faster. If it's too slow for you, let me know. I'll make it faster. And we'll try, right? So that's definitely something that we value. Now, how we contribute. We've been opening issues and we're trying to make as detailed as possible with examples, right? How to go ahead and do that. So if I show you, for example, some of the issues we have here, right? One great example was the process priority. I opened this issue explaining like what the problem is, right? What the thing we want to achieve is, some implementation notes and a testing idea, right? And within 6 hours, I'm not cheating you. This was what? 10 p.m. on January 1st. This was created 4 p.m. 3:46 p.m., January 1st, right? So 6 hours. We already had an implementation that was merged because we value being able to describe the issues and getting people up and running. And John, this was Leads John's first contribution to the core. Definitely want to do that. On Minty, unrelated to this specific part of the stack, right? But if I open Minty here, we've had a lot of PRs already, like what, 7 different contributors to different parts of the system. Because we've had PRs saying, hey, this is the direction in which we're going. We want to be able to have all these nice things, right? Help build any of them. Here is a reference for how to build them, right? Just pick the one you want to build it. And we've had tons of PRs for that as well already. The last one we currently are having here is about adding key bindings, right? I don't even remember if the key bindings were here. Yeah, we had them there. And Charles has been super patient, super amazing at sort of the working with my feedback, right? And refactoring some of the things we had. So we find the most usable possible thing, right? The simplest abstraction that will get the job done, that everybody can work with and understand, it will be fine. People will be able to build things with Minty and say, here's my key binding, and it will just work. So something we care, how we contribute, right? And hopefully that will be enough for you to say, oh yeah, this sounds like a nice, fun place to work at, right? We are also sort of doing a lot of work in public. These streams, right, are definitely part of that. So I'm hoping that all of this will encourage other people to get involved in these different layers. Felipe was the last one to sort of reach out and say, hey, let's build this one thing there. And we're now building the whole ByteString sort of package together. And it's just absolutely amazing to be able to do a collab out of the blue, right? With someone so like, you know, super knowledgeable, right? In this sort of aspect of domain, which is building low-level infrastructure for managing strings and stuff like that. He's been working with Apache Arrow, for example, right? And also happens to be a really nice guy. So, you know, win-win everywhere. So I'm hoping that these attitudes that we're putting out there with these first vertical slice are going to get people to join and help. Paste. Yeah, so if you're listening and any of the things that I'm saying like make sense, right, resonate with you, then we actually have a tiny Discord where we're building Riot itself. This one. We're not doing much right now, but as we keep building things in public, right, we'll build more things for Riot in here. So I expect this to be more of a very technical, like contributor sort of server, right? So join the thing and reach out. I'm very reachable. I'm easy to Google. You can find me on Twitter as well. Yeah. And if you can't really do the open source work, because you have other things in your life happening, or you don't care enough, or I don't know, for many reasons, completely valid, right? Then consider as well supporting me on GitHub sponsors. We got 14 amazing sponsors at the moment, and the list is growing. And the whole point is to do this, to get to that silly little ocaml framework for web artisans. Like that's where we want to get. But we want to make sure we're taking the right steps so that once we get there, we don't go, fuck, now we need to rebuild everything. All right. Enough with that. We can go back to building. Oh yeah, I'll put the Discord link in the chat. Invite people. We're just gonna make no limit, generate link. Marsha, it is a joke right now. It is a joke. Yeah. But it's also, it's a joke because this is the Laravel website. that we just changed the colors a little bit and just wrote ocaml instead of PHP. But this is where we want to go. I am so happy that I was not muted. All right. Let's get some guards in that pattern match. Cheers. You ready, Leia? So the last thing we saw, right, was that the representation, when we get, got a blister. Damn, I'm typing so much. Jesus. This representation, right, might be enough for us to turn it into if else. Because we have two things here, right? They have a guard in the middle, but otherwise they have all the data they need to run. So it's either this one or the other one. If we had more, so if we add another case here, right, that is exactly the same, then we would have 3 there. And just for, yeah, let's start with that one. We'll do that. Yeah, this looks a little messy, but essentially is that, right? These two that from before, and then that one over there. So I'm thinking that once we do the first pass, right, for once we do the first pass that creates this prefix tree, right, then we can do an optimization pass. So we rewrite that to this, right? Because this is valid. This is completely valid as a tree as well. It just happens to not have been done that way because when actually maybe we can do that at this point, but when we build that prefix. But because we're only merging 2 at a time and you grab these 2, then they will have a prefix that is empty, right? And that's fine. So we want to map on this one, right? So when a parent has operations that are prefixes, right, and the prefix is empty, then that means there's no difference between this one and the children over here. So we can do that flattening there, and this should change. That sounds good to me. So here we build the prefix tree, right? Leave that open here on the side. So once we fold over that, we can do flatten, right? Or compact. And compact will get a tree, but will be recursive, right? And we essentially want to do a match in that and do prefix. If we have a prefix with operations, right, and it has a body, or I guess it would have more T's in there, this will be a list as well. Then we want to check essentially we want to map over those trees, right? So T is going to be map, right? And then we get a T here. Prefix ops ts. So if we get a T and the T is a prefix and it's empty, right? And we get some ops, some, second tier T's there, then this will actually be a flat map. I think we have concat map, right? Yeah. Then we'll return those two. However, if it's not, then we'll just return whatever we have here. So essentially, these ones have all the same prefix. The prefix is nothing. Then we might as well lift them one level up, right? If it's not a prefix, if it's a try run, right? Then we'll just return that. And I'm trying to get some. There you go. That's a little better. However, when we try to compact anything else, it will just be itself. Because if we have a try run, that's at the very end. And if we do have a prefix that has things, then we just want to keep that. So maybe we will do that. Compact. So save, run it again. And I don't like that it passed. It should not have passed, right? We are on the third match test. I expect this test to fail. Fail for me, please. Otherwise, it's not working. Okay. I think we're getting somewhere. Yes, error in test number 3. Let's fucking go, chat. Not bad, right? Because now if we get that, right? Then we can maybe turn that into something that it would be even easier to work with, right? So we know we have the try run, and that's great. But once we have all of those try runs, I would love to turn it into like guard, right? Or guarded. So we do that. I don't know. I like that we already have flat in that, but we need to find a way to generate that code with this. Because normally, if we don't have a guard here, then this does not work. This is an error, right? So the only reason this is working right now is that we have at least one guard. And even then, right, it's either all of them have guards, right? So if one of them has guard, then the last one may not have one, right? So we need to maybe validate that. How do we make that easier? right. You know what we're gonna do? We're gonna actually try to run it. So wait, which test is this? 4. Okay, cool. And I guess this also simplified part of this tree. You know what? And then we go into, all right, all the way at the bottom. This is gonna change as well, but this is also test number 4. So the last one here. So that goes away, this goes away, and boom, new expression, Dune format, run the thing. Okay, so what happened here? Oh, we don't have guards there yet. We have them here though. So this code that hasn't changed, which is okay, but we need to fix it. So I guess one way of doing that would be to say, when you reach a prefix, right, that is empty, and you have a bunch of things here, right? We can go into the body and we can first check if they're all try runs, right? If they're all try runs, then we can special case that. Because the idea is that you have many patterns, they have the same pattern but different guards, right? And at that point we can say, okay, we are either none of them has guards, right? Or the last one doesn't have a guard. It's either or. If you don't have guards for any of them, no, you have to have. At this point, if we have more than one that doesn't have the same one, then they better have guards. All of them except the last one. Okay. So a list, I think there was something for like every or all. I think, what's the name of the combinator here? Exists. No. Find. Exists is for find one. Map. T. I'm waiting for some comments there, but not coming, I guess. It's fine. If it's a try run, right? We're gonna make a function here for this. Or what do we want to do? We want to check that they're try runs, right? I guess we can do a filter here. Ooh, filter map. Cool. If it's a try run, right? And this is empty. This is okay, this will do a lot of heavy lifting, right? So we go through our 3 checks here. Where are they? Right? And if they all have an empty prefix, right? Then that is a use case we want to have, handle. So we'll do some, and then we'll just put the bodyguard here. bodyguard is fine. Else, anything else will do none, right? Is guarded. Cool. So now that we have that use case there, right? I am tempted to do expression here. No. Anyways, it's fine. If we are in, God damn it. If we are, right, dealing with guarded leaves, we can turn that into an if else, right? And here we'll just do the usual reversing of the cases, right? Because we're going to do a fold. And here we'll get our accumulator, right? Which will be a no match. Will it be a no match in this case? I guess the accumulator will change depending on... no, wait. I'm not liking the way this is sounding out. I do want to put that aside, and I do want to check if we have guarded leaves. And I think we'll have guarded leaves only when the list is entirely comprised of try runs that have no prior operations, right? So if we have many of those, then we definitely want to check that we at least have either... No, that they all have... Maybe all but the last, right? So maybe we can start there. I want a function that if I give it a bunch of try runs, right, it verifies that the last one, right, everything has a guard except the last one, or maybe the last one. So that only matters if we're in an only guarded leaf, right? No. See, like, this is why I think it's important to pick the right representation as fast as you can, right? As early as you can in the process. Because right now, we have to deal with this garbage decision that we made up there, right? Because of the matching lower representation, right? That ends up in this prefix tree, right? Creates this problem. So maybe we'll go through the prefix tree and then we will have another representation in the middle, right? That gets rid of that problem, so that if you have things that share a prefix, then we're guaranteed they have an expression. Fuck that option. Making my life hard. Oh, for all. Thank you, Marcel. Yeah, I did not see the chat. Ooh, we have a meme here. Well, they're opening it. Ohio Tech, bro. Whatever, man. What have you shipped lately? Yes, I think at least for all could have helped. I also feel it wouldn't be that hard to, at this point after compaction, when we have the right tree, right, to go from something that has a prefix of, but instead of having a t-list like this, right, maybe uses a third variant. Not entirely sure though. The thing is, I need state, so I need to fold. And the worst part is that I actually need to know how far along in the list I am. So maybe fold is not enough. Maybe I need to pull that out and just recurse so I can pattern match on that list, right? Because I want to be able to do this. Like, oh, this is the last thing in the list, right? So if the last thing in the list is a try run, right, that has no things and is a non body, this is fine. This is a-okay. So we'll do is valid. I guess we just return, right? True. Now, if we have something else at the beginning of the list that is that, right, then this will be false. Trying to find the right set of parentheses here. So if we are the only thing or the last thing, that's fine, right? But if we have it at the beginning, it's a nope, right? However, we want to be able to just go over everything else here, right? And as long as we have something, then that will be true, right? And is valid. Guard the leaves, rest, and then we'll do. Actually, we don't need that accumulated there. We can just do the ugly thing. Non-tail recursion. This is fine. Don't care. Yeah. Like that. If you find anything else, right, that's instantly false, right? This can probably be written more succinctly, but point is like that, right? This is what I want. And, fold is great, but sometimes it doesn't cut it. Yeah, but I need state. And I could do the rev in the fold, right? And start at true. And then if the first one, how do I know I'm the first one? That's the thing. With a fold, you don't know where in the list you are. Unless you keep track of it, right? Unless you're actually rebuilding the list, then you know. Okay. Yeah, but you're saying first one, and he's like, I need a marker for whether I am on the first one or not, right? Like, I need to thread in all that state myself. And I think this is much easier, personally. So you're saying do a list rev here, right? And that would be the last one. But if the last one can be none and can be some as well. So the last one of the cases that shares the same pattern, right, may also have a guard, and that's fine, right? Yeah, I understand what you mean. You grab the first one and based without like the last one, and based on that, you can decide whether you're gonna expect everything to be a sum or a non, right? But it's not the last one that. No, actually, if you do. Right, you grab the last one, right? You check on that. That one is always okay. And then you check the rest is always some. Okay, let's write it that way on the bottom and see what happens. So list rev t with, right? We expect the first one to be try run or whatever, right? And this is fine. and then we get the tail, and then we say list for all, right? And then we need to pass a function here, and that function will need to match also, right, on f. And I don't know if I would like this, but try run, right? And if it's a try run, then we'll do true, else we do false, right? And for everything else, we do false. What don't you like? Oh, this is with. I don't know. I never checked the last one. I do. I checked the last one. Because I don't have a rev here, right? Right, so that's what you're trying to say. Like, the last one we don't care about. That's what you're saying. No, fuck, I lost your implementation. God damn it. Stupid Vim. Sorry. I would do it, but I really don't like that I have to do another match. Nothing with it conceptually or anything like that. I think it's fine. Just that. Oh, here it is. Here it was. Still. So we don't want that case either because it's covered here. Okay. Damn, it went so quick by. Where are you? 8th run of the Quake 2 soundtrack. Ooh, yeah. Hits even better every time. So, if is valid, guarded leaves, right? Then we will extract all of those pairs, right? And we'll start building the if-else chain. And if all of them have a sum, then the last one will be no match. Or guard mismatch, raise exception. Okay, so build if-else. Else we do that. Cool. If we have a non here and we have a body, right, then we want to fold starting with an exception. Okay, so let's do this. Bodies, and then last. However, if the case is that we do have a guard, right? Then our bodies here will need if we do have a guard, then the last thing in the body needs to be expression, raise, byte string, guard, mismatch, right? So this will be a list of that, and this will be an expression. And if we do have anything else, we'll fail with invalid. We found a list of prefixed operations that are list of pattern of branches. We found branches. Yes. Okay, no. We found branches that share the exact same prefix. But somehow, I don't know. I don't know. This is just invalid, like invalid guarded body case. We should be ruling this out right here by checking if it is valid guarded leaves. Fold left, we will have our folding function here from the accumulator and the body, right? And then we will start with the last, and then we'll just go through. I think it'll make sense to do T, list rep T, because we need to go backwards anyways, right? No, never mind. We need to go through bodies. Cool. And then each one of this will essentially be if guard, and we need guards in all of them, so we are guaranteed that there will be guard. No, Leia, go away. Okay, guys, time to pet the pet. Mwah. She's so pretty. Oh, it's Saturday. Oof, damn. What don't you like? accumulator element accumulator, and this is an expression, and we get here bodies is a T list, right? So it should be fine. What don't you like? Hmm. Hey, what's up? So, I mean, yeah, my sleeping schedule has been absolutely terrible lately. So I wasn't quite sure if it was Friday or not. What am I missing here? Fall left takes the function accumulator and the thing to iterate. And this is our T list, and this is our accumulator, and this is our function, right? Is it a problem with this function? It is. Okay, so I think I can get rid of all of this weird. We don't need that anymore, right? We can just do the act there. Because we're not really using that expression at all. Oh, I think it worked. So before we have that code, and here on the right, we have better code. So I'm gonna just replace that. Yeah, that's about what we want, right? We got this one, and there's another catch there, right? So that will just be they're the same, except that the first one has a guard, right? Because the guard runs on the first one there. Cool. So we can probably go to the bottom of the test now. Or where was it? Oh, the PPX, yeah. Neat. Describe. Cool, no worries. line 902. We are not really using the line of code here. If we're not using it, then we don't need it. (917). The guard is not being used when we do this. Why? To expression, right? I think we probably want to call build body instead. Oh no, what do we do? So when we have one of those, we go to build body, and build body either yep, sorry. That makes sense. It will just have to stay that way. What the hell am I doing? Cool. So format now. Okay, so let's read through this by pattern PPX test. Pattern 1 and pattern 2 are the same except for the guard. And what we get is that all the prefixes shared across everything. But at the last moment, when we have the last 4 extractions, right, including the empty expect, we will check. So here we'll do something. Maybe we can even pass in like thin and payload or whatever. Cool. So if the guard passes, we do that. Else we do the other thing, right? Now what we want to check is with a larger example, right? And where the hell do we have that example? I swore that we ported it. Oh no, here. Ooh. I think we have an error somewhere, right? Okay. Time to check. Oof. So just for sanity, we're gonna where are we? We're here, we're there, we're every fucking where. We want to inline some of those things so it's a little bit easier to read. What do you want? Okay, so we're missing something here, which is that the guard was not actually used when we're not sharing the exact same prefix, right? So we also want to test for you have a guard. You want to use the guard, right? Which is very reasonable. Cool. So I think the problem, right, is here. Because we almost never get here on our own, right? But when we do, like we only go through build body, right? When we have more than one thing to run. And then for each one of those, we go back here in case that there are prefixes as well, right? So maybe in this case, right, we should handle that. So if we have guarded leaves, that's great. We can go ahead and do that, right? But if we don't, right? If we just have a thing that has a guard, I don't know what that tree looks like. So maybe we want to add some tests to that first. Let's see how we're doing though. 747. We don't need the lock anymore. Great. We're still passing everything, which is great. A nice little battery test, isn't it? And they were pretty fast. Happy with that. Very happy with that. FP. Based. Okay, so that means we can go. Doesn't make to go to elixir, but we can go up to. Where the hell are we? Byte string matching tests. Prefix optimization tests here. We can add a test, right? Where we just have one thing with a prefix. Like that, right? I don't know what happened there, but something broke. Oh, test number 5 changed. Why did you change? Okay. So let's see test number 4. Let's see what output you generate, right? When we use you as one of these tests. Okay, that is not wrong by much. So the problem here is that we're not really calling our guard at all, but that makes sense because we have not enabled it. And if we do guard and we do expression, run guard, right? Then that should fail again. Actually, this is the what? Yeah, okay. It didn't fail because it doesn't do anything with it. So it's very, very wrong. So let's break that test. Kind of love saying that. We're listening to the Quake 2 soundtrack on repeat. We've gone through it 8 times so far. No worries. So we need more state. When we call to expression here, right, we don't know where we are. And it turns out that by default, maybe we should raise on guard, right? Right. If we have skip guard on, or option is none guard, right? So the long way will be to do that or this, right? And here we'll do when skip guard, right? Now, if we do have some guard here, then we want to do this, where the else is just going to be our throwing. So we don't really need that any sort of wrapping around this. We just say else like that. And the body is going to be called to that thing. Oh, sorry. So maybe we can just make a little matching here and the guard and the width, right, and some, right? That might be a little cleaner. So then we can also just do let body equals that, right? So if we don't have a guard, then we'll just return the body. Else we'll return the body inside of the guard. Cool. Cool beans. And that means we need to call skip guard now. So the first time we call it, here we'll say skip guard false. However, when we call build body, right? Build body will say skip guard true. Or will it? So what happens if we remove that and we just deal with the guard as it is, right? Which I think is like a natural thing to do. Yeah, a guard, you use it. Okay, so it does the opposite of what we wanted to do. It runs the guard first. But we can't do that because the guard may need access to the things that you match on. So the problem is the body, right, should be that, maybe. And then we should return that thing with the body. Yeah, that I like. I like that. Cool. So what else will break if we just change that? So we match everything, and then we run the guard and be like, hey, is the guard good, right? If it is, great. Else we do guard mismatch. And I think the guard mismatch is just going to become a no match anyways. So it should be fine. What the fuck is this? Match test number 4. Okay, nothing else broke. Looks good to me. And our PPX, how's it looking? PPX test. We need to make that test better. So we'll do compressed. That's good. Something happened there. Describe, Dune format, right? Let's see, describe, expanded, right? So race, guard mismatch, unbound module, that. So we have the right guard run everywhere, right? Which is good. And then we have a guard mismatch exception. And I think this is failing because byte string ML does not define that. Exception, guard mismatch. If we do that, unbound what? Oh, byte string ML, MLI. What? No, what the hell is this? Guide mismatch. There you go. Guard mismatch. Guide, guard. Cool. Okay, so definitely not bulletproof, but we have support for guards. And if you match on one of those guards, right? If you have the same prefix, and there's many things with the same prefix and different guards, then it will actually become an if else across those things after everything has been matched, which is pretty nice. So we can maybe add one test that makes that very, very obvious. That it maybe is not so massive as this one. Wait, we do have that test already. Is test number 4, right? No, this is for a single one with a guard. And then if we do 2, really? No, test. Oh my god. That should fail, yeah, perfect. And this test will make it very obvious that that's what's happening. I mean, maybe not obvious, right? But at least it's clear here that, oh, hey, same pattern twice. The first one has a guard. Then we do the same thing for both, right? And then we have the guard. And then based on the guard, we do E for else, right? Because the second one doesn't have a guard, right? And now I kind of want a case where if we add a third one, I expect this to fail. It didn't fail. It didn't do what I thought it was going to do. It doesn't do something that's wrong. Because we do run the guard first, and then we run test body. Okay, I think I would like some tests, right, for the PPX itself that we can use cram and describe for. And I remember somewhere around here, somebody dropped a few very interesting links. Cram tests like that one, and I think it was touching both. There. Oh yeah. Okay. Excellent. Cool. So we'll set up that test now, and once we do, we can look into error reporting so we get some nicer errors going, right? Because right now it's like, oh, failed. What happened? We don't know. Oh yeah, project year. Okay. So we can do Dune, describe, pp, right? Test ML, and that should be cool. So run T. Cool. So ppxt Dune, and this is actually ByteString ppx, and it's still a library that's not found. How do we make this? Do I need to install that library to be able to test it? I don't want to do that. I want to be able to test it while I'm developing, right? Okay, so ppx import, right? Has ppx deriving and has a file there that does the heavy lifting, I guess. And this is not really testing the pps. Okay, so it does that. Stage pps, ppx import. Maybe that's the thing we need to do, stage pps. Nope. Stage pps are not supported. So where does this actually find that? Because we don't really have a Doom project all the way up. We have it here, right? So the Doom file there does that. But then run T. Creates a new package. So maybe I need this one level up, right? I think that's how you would call it, right? It's called ByteString ppx. So we're gonna go back to those tweets. Here. So I set something up, but can make it run. Thinking. It's missing a kind, the PPS library, which is a bummer. Roughly, I have this structure, these files. Byte string, tune, I heard a poke, but I don't know where. Oh, maybe here. I really like Dream, and I also really don't like it. I feel like the approach developing absolutely everything on that single package, I don't see that being something that you can build a large community on like that. Not that you need the fragmentation, but you need concerns, right? You need to say like, okay, this is the one thing and that's the other thing, and then you deal with those separately and you version them separately and stuff like that. Not saying that Dream can't make it, because you can definitely build things with Dream, right? Run number 9. Here we go. So I am not sure what the problem is here, right? My guess is that if we do install or we pin to the local version of the development, right, that package, so if we do them build, some things would fail there, it's fine. And we can do opam pin byte string, right, 001, and then we'll do byte string opam. I think we need to do that dot. Hey, thanks for the follow, Curiosita, Sander Monkey, and Rady streaming. Cool. So if we do that, then I would expect the test to maybe work. Hello, Ethan Shell. How's it going? Weekend. Am I right? Exciting. I saw Dimitri asking about Minty in the Caravan, a big Discord for ocaml streamers. Ooh, I love the song. Okay, so the library is there. What the hell? Am I not exporting this correctly? Maybe not. Let's see how other people have done it before. So in PPX import, right, we have a Dune project here, but it doesn't do much more than that. Name PPX import. So in source, right, we have a public name. We just search for it. Oh my god, sometimes I don't get it. Ocaml, opampinat, right? Byte string 001, and then we'll go for byte string.opam, right? But we'll do a Doom build first, so it's up to date. And that didn't work. So now I would expect to be able to run Tune Test Air and get something new, but no, we don't. We do not get it. Why? Why are we not getting that? So preprocess pps bytestring.ppx, right? Haha! Gotcha. All right, so that's a problem. So that's weird because I really expected to be able to use, right, something that's in the package, in the public package, right? So you have a bunch of libraries, you say, these are all part of the public of this package, but you need to go through the public name, which is kind of weird. Because you cannot really access modules through the public name of the package, right? You have to have an additional public name for the thing that you want. But I also, this is weird, because the name, right, here can't have a dot, but here it can. And I've seen all the libraries use this approach, right? Like ppxlib dot meta quote. Anyways, so that works. We get our compile thing there. So I think what we're gonna do is we're gonna split that, this big ass test.ml, we're gonna split it into a bunch of tiny ones, right? And we're gonna run that. Now the next thing would be, how do we test this thing without having to install the package, right? So we left a comment there. Managed to get it working by one installing of pumping. And I think the problem is that if I remove that, and I unpin it, right? So this should point nowhere. Perfect. And we can probably get rid of that, right? And run again. Yeah, okay, that was that. Perfect. This runs without needing to be installed. we're so back. Cool. Love this. All right. So let's go into that folder and do things to that test file. ppx test, right? So we're going to do an mtml, right? And it will just be that. Cool. Test.ml. We can get rid of that. We want to do construction, right? A few construction tests. So these all are very tiny. We can probably keep him like that. That's fine. These matching ones, we definitely want to split up, though. Cool. So we'll do a build, right? Just so that we know the code is good. And then we'll do a couple of this, right? So we want to grab MTML. We want to grab construction ML. We want to grab matching ML, right? Cool. So now we have a couple of those. Hey, Gokai Buruk. Thanks for the follow. So now let's see why it fails to compile, right? This is unused. Is that all? Is that the only thing you don't like? Yeah. All right. I like it. Set up PPX black box tests. Black box tests. Yeah, whatever. So now that we have that, we can probably start making error files, like with specific errors. And we want to check exactly what error we get out, right? Whew. So let's do into empty. And then we can do error empty comma. So we want to make this an error, right? And if we run that, the tests, nice. So we see the thing there, right? And we would see that when we call build, right? But we want that to not be an exception field error like that. We want it to be a much nicer error. So we can learn from how others are doing this. Okay. Race error. But that sounds like a reasonable thing to start with, right? In by pattern, there are some places where we need to have a location. So the transition builder, right? This is for creating things. And we definitely want to be able to do that. So what we can do is just say a try here, right, with error, and we'll get a location and an error. And then we can do some nice printing, which is what they did here, right? We'll just want to grab the error and a similar error than they have there. So parser stuff, that's too early. Construction lower, too early. Function builder, so we can do that. And I would like this to be called fail, right? Why don't you like this? ppxlib dot. So that's a nasty thing I just did, right? Replacing the default racing exception with something that would by default be nice. Well, we can do that. It's okay. I think maybe we want to grab that stuff outside, right? In the PPX. So we do that. And we go to our definition here, right? So I can define that there and define location to be empty. So by default, we use location none, right? So 693, there will be some places like way earlier than everything else. No, you know what? I think we're gonna make them mandatory so that if we fail to add a location, right? That's because we need to thread one. So token needs a location. Expression needs a location because we're definitely passing that around. Read needs a location, right? String needs a location, right? So that puts the burden of specifying where the hell we are to whoever needs to parse. And that would ensure that whatever we do, we will always get a nice message. So parse location, right? Elixir read location. And then we'll do parse location there, and we'll just thread the location patiently. It's not so bad. 390. Fail with location, location, right? Location, location, location. So when you do create ops, we also get location there, which means we get a location here, which means we get a location here. So line 366. $398. Oof, tons of places. Look at all the locations. Look at that. We had a location there already, so we called it. Perfect. 674. Come on, we can do this. It's not so hard. Just a little boring. Create ops actually takes a location as well. Doesn't it? It should. Now it does. Six four two. Take a location, which means lower takes a location. And if lower takes a location, then 701. Location, 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 location. 834 gets a location as well. You get a location. Everybody gets a location. Which is not the same as getting a location, right? Almost there. Now we can go into PPX byte string, right? And everywhere here, we want to actually pass a location. 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 No, so the location actually comes all the way from the top, right? We're just passing it everywhere. Because usually, when you do a PPX, you have a single point in the source file, right? Where something is going to be extended. And that is the location we want. So we can attach to that location errors and things like that, right? So byte pattern test, right? 19 actual, so we need a location here as well. And we actually have a location somewhere. So in this case, location is going to be defaulted to none, which is fine. But we need to pass it around. 134, lock, right? 201, lock, and then lower actually also takes a location. And then 366, what? No, 336. That also needs a location here. We're parsing 449. Same, lock, right? Exactly. The location of the expression being parsed. We could also, right, when we parse at that location, right, expand that location because we know what new code will be generated. And then we could track that around in our AST itself. But our AST is pretty dumb right now. It's just a series of like operations that you want to run. Hola, Cristian. Gracias por el follow, channel. 596. We go there, and then 748. Lock. And then 7, what? We just did, oh, we need it here. And then 1066. Oh my God, we wrote so much test code, folks. Like crazy amounts of test code. And then that's it. Now we need to figure out why the hell this won't work, and it should be okay. ppx. We have ppx open. Right. So we don't want to, we want an expression. So what we have here is a pattern, right, for building extensions to the module type, which we don't have, right? We're actually building with module items extensions. String, struct, m. The hell do we have here? P. P mod extension, no. I guess this will be a module expression. No, we need an actual expression. P str, P maybe P extension, structure item. No, we need something else. PX extension. Woo! Yes. Okay, that's not bad at all, right? The byte string syntax supports writing commas, but a single comma is not a valid byte string pattern. Not bad, right? Now I want to try another one here, which is like hello, like that, and then we do UTF-9. Okay, we can fix that string, but not bad. This is actually helping a lot, right? Like pointing at, hey, this is where the error is, and we can actually construct a nice message for it, right? We found invalid data. We definitely don't want a pretty print like that. Oh my god, it's so embarrassing. We do elixir to string. And when we go, we need to implement that, right? We don't have it, so we'll do elixir to string, and then we'll take a series of tokens, right? So if it's empty, empty string, else we get a token, and that token is going to be pretty much this, right? So we kind of want to reconstruct, right, the same string that you had. And in this case, that will be name, right? And then TS. So we'll just concatenate that to string TS. Comma is just going to be comma. We don't read, this is too much. We'll just do a map here, right? Lista map font T. And then we get 1. So it's a little easier to just do that. And then end of file is going to be that, I guess. Number is just going to be a number. So we're just going to do sprintf on both of this, right? And then expression. Ooh, that's a juicy one. We're just going to do the same thing. Sprintf, and we'll turn that expression into a string, right? And then we'll do list concat, right? And then we'll concatenate them with nothing. Sorry, string concat. Sprintf. Better? No, that didn't even type. What the hell are we talking about? We want to call that function, right? Okay, a little better. I'm not a fan of all of these white spaces that are being marked there, but and I think we probably can just move all of this to the left. I don't get all the new lines that we get there, but dope. Okay, so let's see. Let's see what else do we have written, right? Invalid size. Ooh, this is a beautiful one. So invalid size. I wonder if we can do that for more than like this. If we have two of those, right? Do we see both errors? No, we see just one, right? Invalid size UTF-8 for number 2112. UTF-8 sizes expect the value to be a string literal. I would love it if these errors were more spaced. Just give me room to breathe. That's so oxidized. The hell happened there? To be honest, since we're just getting started shaking up this place to build the first frameworks and labs, I think that day is very far away. The thing I'm most tempted to do is, as soon as we have the website the listener is working towards, make one last final attempt at semantic social app. Nice. And then that's so oxidized. Lol. Cool. So now we want to do bytes, right? Invalid number size. I would love to be able to collect more of these errors, right? So maybe just we will look at the yeah, I think that makes sense. So let's go to fail with right, the definition here, right? And we'll get a location and an error, which is a string. And just to make sure that everything is nice here, whatever error you have, we're gonna add two new lines too. And I think this might add enough spacing. Yeah, between errors so that it's easy to be like, all right, that's the one thing, that's the other thing. But however, what I think will be even better will be not to raise here, right? But to do accumulate the errors, right? So we can I wonder how would that fare, because we can really. No, never mind. I think we can't do that right now, because the way this is designed is that if we can parse something, then we will blow up. So at least this will give you nice errors out of that. So that's the one that's invalid number size. But I want to also try bytes, right? And we have a different error message for that. So maybe we want to make sure it's the same error message. Expects. Hello, Crado. How's it going? Cool. Based. So if we do UTF-8 and we pass like 10 here, right? Then it will show us that invalid size UTF-810 for number 2112. So this is pretty good. Hey Credo, sorry to hear that. Sending you some energies. We're building ocaml stuff. I don't know what languages you speak or write. Hey Glitchbite, how's it going? Dude, it is going amazing. Amazing. Yeah. We're building an extension to ocaml so you can do pattern matching on strings. And we have built some of the basic things, and I'll show you some tweets here that are kind of cool that show what we can do, right? So this is the first one, right? You can do a match, right, on a string, and you define how many bytes you want to grab or which bits in which order. And then this will generate a bunch of code to very efficiently, right, grab the data you want and then call the branch you want. This is not possible in ocaml at the moment, right? So it generates some code like this. But then, Frederick, if you're watching, right, he was like, oh, but Erlang has always blown my mind that the pattern matching is compiled to this nested switch statement to do as little work as possible, right? And I'm like, this is kind of, it does the trick, but is it really what we want to do? And it does not. So this reuses a lot of things, right? Like the same pattern over and over. But every time you go into a branch, you are potentially doing all the work. So we did an optimization that once you have patterns, we find prefixes. We build a prefix tree, right? And then we only do the bare minimum we need, right? So here you can see that fin and comp are shared by all of these three top branches. So in this screenshot, the first things we do here are to get the fin and comp, right? And if we fail to do that, we will raise an exception. So the first try will take you to the last branch. Boom. That was great. That was so much fun. It has some errors though, and the problem was that it doesn't support branches. So then we did something else. We went ahead and we added support for branches. So now if you go into our test, pp byte pattern test, no, god damn it, there you go. If you have these two expressions that they're the same, but we add a guard to the first one, you'll see that we do all the work, and then we have a guard, and we do, if the guard passes, then run this thing, because the expressions would have exactly the same sort of capturing patterns. And if you have ones that have different capturing patterns, like this one here, we grab the first two, we run them, and then we check, is the guard passing? Yeah, we'll run the first one, else the second one. We also have some tests, I think, somewhere for the case where we do not have extra branches, so we just raise. But I think we put that into the new test that we're writing, so somewhere in here. Yeah. So this is a much more complex case, right? So it gets really hard to read very easily. But the idea is that we have this matching ML, right? This thing here. And specifically this one over here, right? Where most of the prefixes are shared. And then what we end up doing is saying, well, we're going to check that that particular guard, and if we do the thing, then we compress. But since there's no other pattern that has the same prefix, right? Then if we don't match the guard, then this will be a guard mismatch, and then we just raise, which will be a fail. And then after that, because we've been at it for like 8 hours today, so it's been quite a day, we started working on fucking error messages. And we should have started here, to be honest. But look at those. You can ignore the red stuff, it's just the diff being annoying. But if I show you the run T here, somewhere in here, why are we not promoting those? Auto promote. Cool. Seriously, look at that. You have a comma in the middle, very common when you're removing things. The bystring syntax supports trailing commas, but a single comma is not a valid bystring pattern. You put a number, a literal, and you use an invalid size for it. The invalid size UTF-10, right? 10 graphemes of UTF-8. For number 2022 is invalid. UTF-8 sizes expect the value to be a string literal, right? If you do hello UTF-9, we found an invalid size, UTF-9, right? Valid sizes these are the valid sizes, right? And these are some examples here. And I need to figure out how to uncheck those. So I might actually just use strings here. So yeah, Crowdo, I don't know if I scared you already, but we're very, very, very excited about ocaml and building cool things in it. Things that have great developer experience. So hopefully some of that energy rubs off on you. So I really want to be able to also do the bytes message here. So number, so we'll keep that one as UTF and do a number size as bytes, right? And then also save bytes where we actually specify the number of bytes. But I do want, let's see if we actually specify bits. Bits is good, right? We can do bits. I don't really like when you do that. Okay. That's fine. I don't know. I think this should fail. Maybe not. But then if that, then this should be fine. Bytes 10. Okay, so that's fine. 10 bytes for that number. Huh, okay. So the only one that does not work is this one, and that should be okay. Perfect. We can probably find the other error here. So how do we escape this thing then? Because I want to be able to write that, right? I think I'll just use regular strings here. So ready, right? Same here. Yeah, I think we probably want to do a similar thing here where we say like found an invalid size for, but specifically say valid sizes for number literals are these ones, right? I think I like that better than what we currently have here. Though I like that we have the actual. What the hell is happening? Copy, paste. Seriously, Bim? Sometimes you disappoint me. valid sizes for literal numbers are bits and a number. For example, we also have bytes or bytes expression, right? Use 2112 as a 10-byte integer. Use 2112 as a len bits integer. Use 2112 as a 7-bit integer. For value d. Oof, these error messages are gonna slap so bad. Okay, so now we have a similar problem down there, which we try to specify the length of something, right? In fixed bits, and we don't have that. Like strings are just not going to be in bits at all. And this will be fixed bits. And then we'll do bits, right? And then a string of int. And then dynamic bits that I think this is just that, right? Yeah. Invalid size for value. We already have the value printed, right? Right? Yeah. Valid size for string literals are bytes, UTF, 8. And number. Actually, a number is valid. It's like if you do 8, that's 1 byte. But I guess if you do that, then you can just do bytes and then do 8. So we'll do that for now. And that. And this would be as size. Cool. So now we want to do invalid string size rush, right? And we'll do 2112 there. And that should fail, saying invalid size 2112 for value rush. Valid sizes are bytes expression, UTF, and UTF-8 expression, for example. And now we need to change those examples, right? So we can probably even put that there. I don't know how that's going to look like, because you could have a really big string that then it just messes up all your messages, right? So I am going to use rush as an example right here, and then we want bytes. Use rush as a 10 byte string. and then we want to do bytes, and this will be use all of the rush string, right? And then we have UTF-8, right? And I forget exactly how Elixir handles that. If we do rush here and we do UTF-8, I think it's going to fail. No, okay, so it interprets, use rush as a valid UTF-8 string. And then we also want to have UTF-8 10, which is use 10 graphemes of. We'll see if that use case stays with us or not, or if it goes away, but it's a start. And I think matching ML has a problem. We need a string to match on, so we can do byte string. There you go. Cool. All right. Yeah, we have a bunch of stuff we're not really matching. So that's both great and terrible, because now we need to actually go through all of these things, right? I wonder if we want to ignore them by default, right? Because one issue I see is that if you ignore them here, right, then that will be a different pattern than if you ignore them here or not. So maybe we want to do that. So for the sake of this example, I mean, this will compile the same, but then it will just be less efficient. And then this one. Actually, fin we can match together fine. And payload as well. Yeah, so that changed a few things around, which is fine. I just want to get rid of the unused variables, right? So mask, payload, rest, fin and comp we're using, that's fine. Line 26, we still have them, do we? Oh, are they here? And that was that. And now we're gonna play it for the, was it 9th time last time, chat? Do y'all remember? It must be, because it's roughly an hour, right? So 57 minutes, and we're at like 8:39, 31. So 57 by 8 hours, right? Or 8.5 hours. That's 484 minutes. If we divide that by 60 per hour, yeah. Yeah, we've been listening to this soundtrack on repeat for 8.5 hours. Just rubs me the right way. You know what I mean? So, so the nice thing about that is that now if we go to our byte pattern compiler, right? And when we generate the code for any of the let expressions, right? There. No, actually here, right? If we do ID lock name, right? ignore immediately whatever you're matching on. Quake and Minty. Now we don't need to do that. But I'm not a fan of it affecting the renaming of things. Oh shit, I changed the file. Okay, just entertain me. What would happen if we do that, right? We would have one unused less, right? No, I don't know what I'm doing there. Beautiful tests. All passing. Okay, fine. Back to the errors. Come on, we can do this. We go into the byte pattern compiler, right? And we'll search for fail with, and we'll start looking. Oops, this is definitely a weird error. Like, we should never get here, right? If we get here, then please file an issue on. Okay. I am confused. Do we have the same errors that we just did? Expect. Oh, right. So this is for matching, and which is different than for constructing. And so far we've been only constructing, right? Glitch, I tell you, if you're down, right, we could do a little bit of homework separately, and then maybe a weekend we spend like, I don't know, 3-4 hours on Discord or something like that, so we have a better feedback loop, right? And we just get it working. Because I don't think it would be that hard, honestly, right? Like, conceptually in my head, it's like there's these 4 or 5 functions we need to implement, right? And we just need to run like the main loop of Doom on a separate process, right? Like on a separate like thread. So if we just run Doom there and we make those functions, right? If we figure out how to make those functions send messages to the Minty app, right? Somehow. So maybe we could start with much smaller thing, like how can we send a message from Z, like some C code to Minty? If we get that right, then it should be fine for us to like even do all of the like literally grab Doom ANSI, Doom terminal, right? And just make it send the view to Minty, right? That would be a great start because then we can start figuring out like, okay, who is going to handle the input? Is it going to be Minty or not, right? I don't know. I'm just spitballing here, but it just sounds like such a fun thing to. It's going to be. I assume it's going to be crazy frustrating, right? But it sounds like a fun thing to spend like and waste hours on. I think it was Doom Terminal or Doom ASCII. Yeah, this one. Hey VMBN, how's it going? Thanks for the follow. You doing okay? Unboxing so local business. So oxidized. Very borrowed. Oh yeah, I don't know how the alerts look though. I think one of the downsides of OBS is that it doesn't really put an overlay on top of your screen. So I don't see the chat on the top right. I wish it did. It'd be amazing, right? To do that. I don't see the alerts, the reactions, stuff like that, right? Which I don't know. I feel like it would be more genuine if I am just sharing the screen and I see the same things you're seeing, you know? Oh, they do. Okay, stream elements. Okay. It hasn't bothered me so much yet that I would build something for it. But I was thinking that it should be possible, right, to build an always on top transparent web view to put things in there. And if that was the case, then we're so back. It's very based. Yeah, it's borrowed literally. That makes sense. It's like that is the dumbest thing I can think of that would work. Okay, so we have a couple of construction errors, right? And on macOS, you can do windows that are always on top, right? I can come here and be like, no, I don't know. Okay, always on top. I don't know. Hey, Ahmed, how's it going? All good? So I don't want to overcommit with the messages because I think there are some things here, right, that make sense. Like you can express a UTF character or many of them as a number, right? And if I'm not mistaken, in Elixir we can also do that. So we can do, for example, H, right? We're expecting, so this is matching, and we could put an emoji here like dog. Hot dog, right? Oh shit, we forgot the thing. Okay. No, come on, just kill the parser. How do I do that? You see what I mean? Like we grab H as a UTF, actually grapheme or number. We're good, we're good. Thanks for asking. We're building nice errors for something that we built. Sorry, I'm brain farting here. The hell, what we're doing? Right. So we're building something called ByteString, which adds support to the ocaml language for constructing and deconstructing strings very efficiently, right, via pattern matching, like you would do in Elixir or Erlang. And right now we're adding nice errors to the thing so that it doesn't suck. And I think the errors that we have missing here, the three main ones, are on deconstruction, right? Hey, Bram, I am I am a developer. I develop things. I have done a lot of things in my career, many of them in backend, but I've done a lot of data work as well, like data pipelining stuff, data engineering, and I've done also a lot of client side work, front end applications, web applications, right? Sync SPAs, that sort of thing. But yes, I build projects I'm interested in, and right now, we are adding nice error messages to. Hey, thanks for the follow, Brown. We're adding nice error messages to a library that extends the ocaml language to let you do pattern matching, right? Efficient pattern matching or extraction, right, of information from strings, which right now you have to do very manually. So this language, this tiny pattern matching language we built, right, looks a little bit like this. Pattern test. So this here, this one string, right, is a description, right, of how you want to interpret a string of data. You want to say like, okay, I want the first bit, right, to be called fin. The second bit we're gonna call compressed, so we're extracting information, right? The next two bits we're gonna call reserved, or RSV. Then I expect 4 bits that are gonna be the opcode. Then I expect the next bit to be the number 1, and the next 7 bits to be equal to the number 127. And when you're wondering like, What kind of nightmare are you matching here? These are network protocols, very low level things, right? That require efficient parsing, but you can use this for absolutely anything, right? If you had like, I don't know, some template that you want to go over and you want to sort of eat characters one by one until you find like a brace, you can do that. You can just say like, okay, give me a character, right? And we want this to be a UTF-8 character and the rest, right? So when you use that, then this will literally be like getting the head. Amazing. If you're into networking, that's amazing. So if you're into networking, you probably have seen something like this before, or if I show you maybe like something like this, you'd be like, oh yeah, that rings a bell, right? This is the description from RFC 6455 of what a WebSocket frame looks like. And this is essentially, right, describing that. So we're building support for this. So when you write this thing, it actually gets compiled to all this code, right, to very efficiently read through that source and extract the data you want with the minimum amount of allocations. It's not a new idea, though, by the way. This is something that Elixir has, and of course Erlang has as well, where you can say, I'm going to grab some data and I'm going to pattern match against it, right? But we're bringing this into ocaml in a way that is like DX focus on the user developer experience, right, first. Because there is another package that does a similar thing, but it's kind of clunky, and it's also GPL or LGPL. So I figured, okay. We have some other issues as well with the internal representation it uses. And since I'm building, where the hell is it? Right. A runtime for ocaml that lets you write applications like in Erlang or Elixir, then this kind of syntax support is just absolutely mandatory. Do it. Elixir is amazing. I love it. Great community as well. Super cool stuff. And they recently started working on types, which is like, yes, big plus. So yeah, what the hell were we? Right, we wanted to keep running our tests here. Let's see what changed. Thank you very much. Thanks, Ibrahim. Have a good day, or evening, or have a good one. Oh, folks, we're one follower away from 600. So fail with invalid size. Okay, so we wanna definitely wanna borrow the format that we already have, right? Ooh, this song slaps. Damn. So here's when pattern matching against. We don't know yet. We're pattern matching. We found an invalid size. For the expected value. Oh, you know what library would be amazing to have here? Oh, Vestig! Hello, Raiders! How's it going? How are you, everybody? Good to have you around. Good to have you around. We're building things in ocaml. We're building a pattern matching compiler for binary strings, which it's something that all the languages have by default. If you go into Elixir, this is kind of the same things that you'll see here, where people go like, oh, I have this binary string, which is just a string of bytes, right? I want to get the head, and I'll take 2 bytes out of that, and the rest. Ron Dev, yes, exactly. That's where we are. This is better as an example, right? You have a string Uber, and then you want to get the X, the first sort of byte in this case, right? And then you want to get the rest. Lul. Gonna do a little shout out to Vesteg here. Thank you so much for the raid. Thanks for choosing us. Keyboard mash. No, I'm pretty sure. Well, actually, I don't know. I do drink a lot of Monster when I code these things, so could be anything. And right now we're trying to make the errors be absolutely fantastic. Which, you know, is not always easy. Let size. And then we'll see the error on the right. And where is the error? Okay, we're gonna first auto promote this outputs because they're good. Today at 9 hours? Yeah, it's a short one. We'll cut it out at 10. I think that'll be enough, right? We don't want to push it too much. Should be fine. Error. And then we're gonna do match error. So these ones are gonna be match error, right? And then here we want to do invalid expected number size. So here we'll do a match of byte string, right? And then we'll just put some byte string here because we want to just get a string to match on. And then here we can say I want the number 2112 to have UTF-8 size, and we'll do nothing with that. So I think this should be an error. Yes. Okay. So when pattern matching, we found an invalid size UTF-8 for the expected number 2112. Valid sizes are for, okay, so that's wrong, but we got the right place for the message. Now, I don't think that this should necessarily be wrong. Because you may pattern match on that like that. I don't know. We found Found invalid size for expected number. I think a little shorter there would be fine. And I think we're gonna go to byte pattern Dune by string Dune. And when we do byte pattern PPX here, we are actually going to include TTY. Or even spices. Oh my god, are we really gonna use spices here? So spices is this very tiny library we built. Oh my god! 600 followers! Thank you so very much. Who was it? What's up? What's up? Thank you very much for the follow. I really appreciate it. And the idea of spices is that you very quickly can create sort of nice colors, right, for a terminal by using actual UTF stuff. True color, right? Like, RGB definitions like that. So I think we could use spices there. That would be insane. Oh my god. I am so happy right now. And this just needs CTY and colors. Let's fucking go, yeah. Okay. So, this is how it works. Okay, let me just walk you through that, right? We first create a color, like for example, a keyword. And then we do spices, right? And wait, we need to probably build this. Why isn't it working? Let's keyword. We'll take a format here, right? And then we do spices, and then we do color, or we'll do bold, I think. Why isn't this working? Come on, just do your thing, man. What the fuck? Color. I am not amused by this. So byte pattern, Dune. And I know why. Because we actually need to add this to byte pattern, the library. Sorry. My bad. There you go. And now this should be like, oh my god, look at that blink and background and all these beautiful things. So we're going to do something easy here. We're just going to do bold, right, for now. And then we'll just build that function. And we'll say, yeah, it will be bold. Is that how that worked? Oh, we need a style to actually capture everything. So default bold like that, right? So far, so good. Now, please terminal work, right? We're going to the expected number error, right? And we will actually make this thing, right, a string. So instead of passing the value there, we'll say keyword, right? And we'll put that there. So we can pre-color our string, right, before we put it into the error message. And, okay, it doesn't look like we can see anything. That's okay. I think this will look good if we go into the actual error. Do build. I want to build here. I don't get it. Hey, Sailing Blair, thanks for the follow. 601. Fan invalid size, UTF-8. Oh, come on. Seriously? This is very disappointing. So we have a Doom project here with all the things we need, but when we call Doom build, right? Okay, that makes sense. Fine, we will pin this thing. And then we will run it and you will see. I don't get it. Why? Oh, okay. So that error is there. It's actually not bad at all. But I expected it to be red for error. And it does not seem like my coloring is making it through. Which I'm not very happy about. So we're gonna try something else, and we're gonna say background is gonna be let's do what else do we have here? Spices or what? Default gradient. Oh yeah, we have gradients. That's amazing. Underline, strike through. Let's see if we underline. Or we have to do this horrible cycle of amending a commit and then pub install. I just want to run the fucking thing. Just why don't you let me? Doing build, so we make sure the opam thing is in place, and we do an install now. Okay, so this is definitely stripping out all the things. The error is not terrible, right? We have examples. We have a good, clear indication of like, this is what's wrong. We found invalid size for value. This is the value, right? Valid sizes are this ones, right? And then we give you examples so you can fit whatever you want there. But I was really, really hoping that we will find some matching errors. Yes! Yes! It worked! Woo! Look at that! UTF-8 bold and also underlined. Woo! Oh, it's barely noticeable. And I think we have some nice error colors in Minty. I forget. I need to look at the. Ooh, that pink one is gorgeous. I love that. Okay, actual library. This one's not so bad. Examples, views, and in main here we will have highlight. I like that one. So I think we'll make that one our keyword. And then our error, I think, so available. What the hell was the name of the thing? Actual library. Okay. So views, main, actual library, right? There's a keyword. Okay. So they call a keyword here, and by they I mean me. But it's really an error, right? So when we say invalid size, we want to just say error, right? Invalid size. Error. I love this. I love how it just takes your eyes, right? You see the thing, it's like invalid size. That's the first thing you look at. Invalid size UTF-8. Okay, I like how that looks as well. But we will definitely need to figure out the right balance, right? Because we cannot make everything colored all the time. Super colorful. But I think maybe we can take the valid sizes, right? And just put them here into like keyword. String, string, string. Oof, I know, right? These are gonna be amazing. It's just a matter of finding like what are the right things for the eyes to go to, right? Unfortunately, the line breaking that we're using here is not escape aware, which is it's a reminder, a sad reminder that we want to use rev term. Go, fuck, what was the name of that package? If I go into bubble tea, so there's a nice package that people have built. I think in mod.go will be there. And reflow. This one? Is it this one really? Yes. And this is just ANSI aware, right? Line breaking. And I would love to build this, right? In one of the layers of the Minty stack. So we can do proper layouts, right? And that would also mean this stuff would not happen. So instead, what we need to do here, right, is to break those into separate keywords. So you can do bytes is one thing, comma, and the other ones. But maybe it would be better to just enumerate them, right? And just say like the valid sizes are this and that. And just have a little explanation of what it does, right? So the first one will be bytes, right? So we're working around the limitation of the terminal rendering here, right? For our benefit, I think. And I think which one's the longest one is bytes expression. And that is going to be how much longer than everything else? 1, 2, 3, 4, 5. Okay. So 1, 2, 3, 4, 5. Dash. Use bytes to match on the entire string. And I think this one doesn't need that much spacing because use. I guess we can just do match on this one. Match on app to or match up to. And then this is going to need a bunch, so we need what? One more than the other one. So here, there. And match on a single UTF-8 valid UTF-8 grapheme. And then this one is actually not so bad. I think it's 2 less, maybe. Or maybe. So 1, 2, 3, 4, 5, 6. Bytes has space, 1 expression, and then parentheses, and then one more there. Okay. And this one should have up to here, I believe. Okay. So match on valid UTF-8 graphemes. So first one is bytes. The second one is this one, right? The third one is UTF-8. And the last one is, well, the last one, right? Do it again. Wait. Okay, not so bad. A little off, just a tiny bit off. I still don't like that this is cutting off the messages. And I wonder if that's... No, it's just capping the messages. What the fuck? Come on. So I need... Much on 1. Valid UTF-8 grapheme. Okay, chat. What do you say? It's not so bad, is it? Okay, sorry. We need to finish the actual contents of the message because right now it's just copy pasta from an old message. So we're expecting a number, which means we can't really use these examples here, right? But we can use these examples. Some of them, anyways. So found invalid size, right? For the, and I think on the error, we're actually gonna make it bold. Valid sizes are for. Oh, we're doing this all wrong. This is the wrong. Oh, okay, whatever. All of that goes here. Sorry, here. So, god damn it. Let me just copy all that. And I'm gonna put it here. Fixed bits, and this would be a string event, and dynamic bits, and right, and this would be bits. Whew. Found invalid size, and then the size, right, for expected string s, right. Valid sizes for string literals are this much. For example, and here we can use the nice little rush examples we had, because all of those are good. Now, these errors are currently a little off with what should be the final state of the library, right? By the way, Sabine, I don't know if you picked it up, but we're using the same color library that we're using for Minty here. So literally, building Minty can help us build better the X in general, right? By having colors and reflows and stuff like that. Okay, so now that we do that, we have this here. We cannot match on those like that, but we need bits, right? And we need number. Nice. And we also have bytes with like 10. That's the example, right? Yeah, at some point we're gonna need to add other things here like endingness, right? Like you're gonna read a number, are you reading it left to right or right to left, right? That sort of thing. This is redundant. And we have and then the next one actually has one space less, so we will need one space more. And this is like use up to X per bits. That was fine. And then here, this is just a number, but we have one less. So we'll need two more than this. 1, 2. Use exactly number 7 bits. Okay, let's see how that works. Might need some. Oh, not bad. Invalid size UTF-8 for the expected number 2112. So I think, I don't know what your things have been, but my gut tells me that maybe we want to highlight the entire error, right, as red. Because right now I see that I have done the invalid size, right, and I immediately see the valid sizes, right. Maybe the color needs to be different as well. Maybe I love this color, but maybe it's not the right one. Like, it's too close. You think so? You think this is nicely highlighted, or should I highlight the whole thing? Invalid size. I think maybe that's what I'm leaning towards, right? So maybe we will use our signature mint color, which is kind of nice. And I know we have it somewhere. I think in the cursor example. Yes. For the keywords, I mean. So that could just be the error like that, right? So invalid size, or what was this? Invalid size. Okay. Hey, Fuming Max, thanks for the follow. Cool. Yeah, I like that. I think I will make that red a little redder. It's a little pale right now, which is not bad, but I kind of want it to be a little more aggressive. Do we have an error here? I think we have an error somewhere. No, we don't. We definitely have a red somewhere, right? No, red. Come on, hands, obey. There we go. We have a red there, and I think that one is from the FPS example, and I believe this one has a nice red. No, that's not it. Alt screen toggle has another one. You can look at that. No, that's still pretty weak as well. Come on, give me a red counter. Why do you have a red counter? That's too... Okay, we're gonna do the dumb thing here and just go RGB, it's red, right? This is full red. So it should be pretty bright red. We want a red that will say, look at me, right? Ooh, that I like. What do you think? Invalid size. It is like, yeah, it's not holding back this red. Come on, folks. 10th round of the Quake 2 soundtrack. It's very hot, yeah. Okay, so now I'll just fix the rest of the messages so they all look the same, right? I like this structure. I like red. This is what's wrong. This is what's valid. And here's how some examples of how you can fix it, right? So in this case, we could also have a line saying replace UTF-8 by, but honestly, I don't think I know enough about how people will use this to suggest how to fix things yet, right? We will know as we actually use it. For the time being, we'll do an error here. So this will be invalid size, right? For value that much, and then we need the size and the value is an integer there, right? So at least this will give us some consistency. And then we go to another we found, and it's the same, but it's for string, right? And here we do s value, and then we just put a string there, right? And we want to copy this. Valid sizes for strings are, and this is for constructing, I think. So this should be almost the same message, but we'll need to double check. So here we expect a string, and the error is about strings. Good. Here we expect a number, and the error is about numbers. That number literal. We want to use this one. So we expect a number, and we have a number. We expect a string, and we talk about strings. That's good. Keep going. We expect a string, and we talk about strings. That's great. And then here we expect a number, and we talk about strings. Right? Not good. Cool. So now we can say valid number for literals. So that'll be great. We can grab that, right? And just put that there. And now string literals are. And here we can grab the same thing we had before. This one. And we can also use that to fix this error. And here is invalid size for the expected string. Hey Nilam, thanks for the follow. So here, invalid size UTF-8 for expected number 2112. I think I'm gonna backtick that UTF-8. I want it to be distinguishable. I don't know if that will be enough or not. But that definitely is a nice error message. Valid sizes are this thing. Now here we have invalid size bytes for value 2112. That's good. Same error message. If we go upwards, right? We see invalid size 2112 for value rush. Valid size for string literals are this month, right? And then we see invalid size bytes. I thought we saw that one already, didn't we? Invalid number size. I think we have duplicated test. Not bad. Okay, so now we have that one, and we need to fix that one. We found that invalid size. No, this is from before. Cool. All right, so this is starting to look pretty nice. I wish we had more context, right, on the expanded string that's going to be used for the error. Or we could indicate more context, like exactly, oh my God, it's 2:30 p.m. already. Jesus. Been streaming for 10 hours. Fuck, that's a long time. Okay. Invalid size bytes. Invalid size. Oh, and this is where you type something wrong, like yeah. Cool. So we want to use valid sizes. We want to put all of them together, right? R valid sizes for string literals. Okay. We want those. And we want those. And I think bytes are the same. So the second one. We're going to have some padding issues. That's fine. We'll run the thing, compile. Huh! It matched perfectly. Okay, because they're all aligned to the bytes expression. Okay, that makes sense. Hot! This is looking great. Okay. Um, what did we miss here? Oh my god. Yeah, so we did that. And I am tempted though by the. This is a little misleading. I don't like it. The fact that we used rush in the test and it's also in the example, it might lead people to think that this is what we are. Like you're gonna replace the error, right? The value there, and that is not true. So the accidentally using rush as an example and in the test case, the error isn't replacing the value in the examples with your own. Because you may have really big nasty strings. Whew. I'm kind of happy with this. This is I can see myself using it and fucking up and being like, oh, okay, it was this thing, it was that thing, right? And this is for creation of values and then for pattern matching of values, right? We also have that. I think we can go a little further because here we know what the name is going to be, right? For match capture so when we do parse size, I wonder what the difference is between those, right? Because this is definitely a parsing error, right? Yo, Nix, how's it going? We're still here, still listening to the same crap. Or maybe your face is because of the amazing errors we're putting together. Oh, who said ocaml couldn't have great UX? It can, beyond what I'm doing here. Doing already is pretty amazing. Did you know that Dune has a TUI as well? That is written using Naughty, no TTY? Dude, yeah, there's no such thing as it's getting tired. It's all here. I like to think that I'm a marathonist of building crap. It's a long amount of hours to build. It takes time. We build slowly, but you get there. Yeah, it has a TUI mode. I don't know how to enable it. I just know it's in the code somewhere. So we're going to pass a name from above, right? Hey, Niliam. Today we're adding beautiful error messages to a binary string pattern matching extension to ocaml. And if these are like words, and you're like, I understand them separately, but I don't know what they mean put together, completely fine. Essentially, Elixir and other languages like Erlang lets you do this. On the right, you have a string. On the left, you say, oh, I'm going to get the first character or the first byte or the first UTF-8 valid grapheme, stuff like that. And ocaml doesn't have that, so we're building that. But we also wanted to have beautiful error messages. Parse size, name. And here will be damn it. I'm happy with this. Are y'all happy with this? So that is a different kind of error, right? Let's see. Dune build, and I think I need the root there, yeah. Watch, display, TUI. What? That is insane. Look at this. Amazing. Can I do something with this? My ear is clogged. Mind blown. Look at that. It even responds to mouse clicks. You can use M. Oh my god. Oh. Dude, this is so good. I love it. Oh. Yes. Yes, 100%. Honestly, if no TTY was not a super type safe, I would probably use it. I love that they also preserved all of the coloring and everything that I did on the messages, right? Oh yeah, we have this one here that we want to fix. Error empty comma, right? And this is the byte syntax. There you go. So format sprintf, right? The byte string syntax. So the error here would be unsupported syntax error. I guess that's just a generic syntax error, right? And then we can have an explanation of how to fix it. But so we'll do error, and then we'll do syntax error. No, no. Half of this is the build system. The build system. This is what I made, right? The other foldable thingy is part of the Dune build system. What's happening here? Val, if you are watching the stream, do not worry. I'll write this down, but completely fine to ask any kind of questions like this, right? I'm guessing referring to the complex pattern matching code I've seen you post in other tweets. Partially. No worries. I put the questions. All good. I'm referring to some code I haven't quite released yet. that is implementing some nasty protocols. SP1U, and and just naturally gravitates towards becoming hard to read. Sure, I could do more functions or whatever, but vertical rhythm is something we need a lot more of in ocaml. Ask me anything about. Alright, yeah, metami writes. Eclojure. Cool. So now we have syntax error. No, that's the last one. We want to do invalid by string pattern. Byte string pattern must have um, 0, 1, or more fields separated by commas. I think so. I think this is about Quake 10, if not 11. I don't know how much explaining I want to do here. Maybe we'll call it a day there. I do want to build better errors, right? But there's a point of diminishing returns, right? Glitch. Russ has meant to ask you how's the TDD works in ocaml. Russ has it built in, but I haven't seen much about it in ocaml. I do need a break. I should take a break. I eat something, and then maybe we can rate someone else, right? Are you streaming today, Glitch? I feel like I don't know when the day went by and it's like 3 p.m. and we've been building for 10 hours. And I'm like, oh, fuck. Yeah, not very healthy to be honest, but it is what it is. This is where we are. And we're going to commit this thing. Oh, we haven't made any changes? All right, we're too deep in there, so we need to go back. Seriously? Oh, sorry. I'm a dummy. I've been doing this whole amend flow, so everything is there in the same thing. No worries. Perfect. Motherfucking 500 to 800 EST. MF. Sorry, I thought that you were, and I was going to ask you if you are, then maybe we could do something. Situated. Yeah, I'm not very good at that. I either don't stream for a couple of days or I stream 14 hours in a row. On the bright side, a lot of people from different time zones get a chance to jump in, right? And we get at least one raid every time, which is good. Sometimes more than one. Once we got like 3 or 4 raids. But then again, it's like 14 hours, right? So, regarding your question, TDD in ocaml. So, I mean, it's Saturday. TDD in ocaml, right? So there's a lot of ways to do this, and I think I like to do the testing right with the least amount of dependencies possible. I know some people like to use libraries like alcotest, right? That will force you to have this main definition of your test suite, right? Unfortunately, I think that is a terrible idea because as your test suite grows and you get bigger, larger kinds of tests running, right? You would put the entry point to running your tests, right, as the single parent in your build graph. So when you modify any of the tests, then you have to run everything, right, together. So I like to do a mix of separate tests, separate files in Dune for different tests. And when things are very small and very fast and I can contain them in some way, right, then I am completely fine having one large test file, right, that has like all of the tests. So for example here, if I do Dune test package by string, right, then as after it builds, sorry, I need to auto promote a bunch of new changes with the new errors and stuff like that. Cool. So let's say I make a change in byte string, right? Oh, that's a good one, actually. Fail with. I think that's the maybe last one that we have that is not nice. Yeah, okay. We have some unexpected characters as well. So let's do that, right? Save that file. If I run this, I expect after it builds, it's done, right? It ran all of the tests so fast because it's all inline, right? In memory as well. So that kind of tests, I have no problem putting all together in a single file like byte string, byte pattern. God damn it. Like this, right? And as you can see, I have written a little test function for myself, right? Where this test function only works for the specific types that I'm going to be trying to test in this specific suite. And I know that the input will be a string and the output is going to be a token list. So this is what we do. And right now, I have pretty printers that I'm going to be using for printing when what I expected does not match what I had, right? What I found. So I'm doing some pretty horrible string equality there, right? For that. If I had time, I would have built an actual equals function, right? to be a little nicer about that. But this is the first test suite, which is the elixir. The next test suite, you see we have a lot of tests here, right? The next one is the parser, same thing, test function, right? Then we have one of the lowerings, right, on the intermediate representation. And then we have the actual construction tests, right? And you'll see the pattern is absolutely the same everywhere, so I don't have to think much. It's like, okay, if I jump to the right test suite, I will see a test function with inputs and expected, right? So that's kind of how I do it. I know that there's other people and frameworks that people would use for doing something like this. In this case, since everything runs in memory, right, and everything is just crazy fast, I don't mind. However, if these were tests that have any I/O whatsoever, then I would not do this at all. I would grab that one test, no matter how small it is, and I will put it on its own test stanza. And maybe people will say like, oh, Leandro, that's so overkill. Why'd you do that? I don't care. So for example, if you go into the Riot tests, we actually have many test files. And if you look at the sizes, they're very small. Because many of this, right, I want to be able to run in isolation, right? And I want to reuse the cache from Dune as much as I can, right? Especially when I'm sort of modifying the tests. Unfortunately, I have not split Riot yet so much that the network tests will only depend on the network parts of Riot and so on and so forth. So Riot is kind of a single thing. But I do want to get to the point where all of the network tests are close to the networking code. So they only test when the networking code changes and so on. Because right now, if you want to run all of the tests on Riot, assuming that it passes, and I think there's going to be a couple of failures. What the fuck? We got some flaky tests. This is definitely starting to take some time, right? It's still pretty fast. But I've been beaten so hard by just folks writing a test suite that has a single entry point for caching, right? So if you change something here, you gotta run the whole thing, or you gotta find the right incantation, right, to just run your test again. We can do much better than that. Like even if it seems like a bad idea to have separate files, because you'll have too many of them or whatever. The default experience of running tests should be incremental, and I think you can get that by having the tiny files. Anyway, so rant over, glitch. Hopefully that makes some sense. And by this point, after 10 hours of just like intense hacking, that the filter is gone, but also I don't know when I'm talking, like when I should just get back to coding. Hopefully that makes some sense. By the way, these failing tests right now in Riot are because of the buffers and how the buffers work, which suck. And this is what we're building the byte string. I can't believe this is so much fun, yeah. Laravel.com, the ocaml web framework. Well, that depends. I want to check what the status is of. I think we made no progress yet here. No, it's fine. Oh, an hour ago. Okay. Amazing. You want to prove and run so we get some CI on that feedback on this workflow. Yeah, I will leave a message for Felipe. Hey, Felipe. Awesome to see this PR. Sparkles. I've updated the other branch with much better pattern matching and with much better errors. Yeah, I think I'm coming down from coding high. I really want to get back to the HTTP1 compliance for Riot, for Nomad, right? We're so close. There's no much things left, right? In fact, most of these are covered. The 11 ones that we're missing, yeah, 11 tests left to go, are related to buffers and reading things from the network and places where the byte string would be absolutely fantastic to have. So, yeah. All right, folks. You know what? Oh, thanks for the follow, Nilam and Zasek X. No, Mandax, you just arrived. How's it going, dude? All good? Liquid phase. Why do you prefer ocaml? Okay, let me prepare to answer that. I'm good, Mandax. All good. It's gonna get some food in a moment. So I like ocaml because it helps me think clearly. It is fast enough that I don't have to worry about performance, right? But it's also garbage collected, so it's not so fast that I have to like just be lazy. I get a nice like, okay, you gotta think about what you're doing, vibe going. The type system is small enough that you can learn it in a couple of weeks, and that'll be it, right? There are some corner cases and some like little places where you can go and learn much more and deeply, but it's very, very small. Generally speaking, right? The 90% that you're gonna use all the time. Which means after a while, right, you just know how things work versus other languages that have massive type systems, right? I like it for those reasons as a tool, right? Compilation is crazy fast, even if you have very large amounts of code, right? Like we're talking hundreds of thousands of lines, and they still compile in a couple of seconds, which is pretty nice. It is very portable, so the code you write here will run in quite a few operating systems. But the real thing that keeps me in ocaml, and I'll be fully honest with you here, is the community. There's a small bunch of people that are super smart, they're super talented, right? And they're kind. They're very, very kind people. Kind. Looking to help all the time. If you like watching streamers, there's a couple that I can recommend that do a lot of ocaml, right? Dylan Mulroy, DM Mulroy, right? Sabine. Sabine actually works in ocaml.org and putting a lot of effort in making the experience for onboarding new people, right? Great. There's also Metami, who's a, I guess mostly does Rust, but also a good ocaml person to have around. Yeah, so those are some of the reasons I like it. It is not the kind of typed functional programming that you get from Haskell, for example. It is much less, let's say, rigid than that, because you can do side effects anywhere, right? Stuff like that. Oh, so you would use ocaml instead of Rust if you want to use Rust, but you don't want to fight the borrow checker. So if you want Rust with a garbage collector, ocaml. Yeah, absolutely. So first shout out goes to Sabine Ocaml. So I'm using NeoVim with ocaml right here. And the LSP works great until you get some, when you start doing weird things with modules. But usually even then, it's just like a restart and we're good. And now we'll do a shout out to DM Mulroy. You gotta follow Glitchbyte as well. They're building really cool, fun things in ocaml, right? I think they're building a port of Doom for the terminal in ocaml. Yeah, I know this shout out limit thing. It's like I should be able to shout out to many people, right? I think. So yeah, Liquid Phase, they're fairly interchangeable in some discussions, I think. It's also an ecosystem that is ripe for innovation. And that is the most bullshitty way of saying it, but it is true. Because it's an ecosystem that still has a lot of, let's call it basic needs, right? So if you like building things, whatever, right? And you have no problem building all of the things that you need to build the things you want to build, then ocaml is probably perfect for you right now. That will change. I think we're all working our asses off to change that. Sabine is sharing my stream right now. Is she streaming as well? Wait, so if I go to Sabine's stream... Oh, sorry. I thought... Yeah. It's just a channel. Thank you. Whoa, you're growing like crazy. Amazing. Okay, so get started so I can raid you. Sounds good? All right, folks. As soon as Sabine is ready, we're going to raid. Thank you, a great toaster. I'm sure you're the best toaster. Miner for miner, yeah, I think we're still missing a lot of low-level things in ocaml, right? Actually, let me show you something. We have this package called ocaml. It's called Owl, and it's built by Liang and Xiaozin. And it is pretty fantastic. Like, I browsed through some of the code, and it's like, Holy shit, they have built so much stuff, right? You even have visualizations. Hopefully they have, yeah. You can do plots. Seriously, people should know more about these things, right? And the documentation is just mind-blowingly thorough. It has all of the things you can think of, right? Multiple lines, box plots, histogram plots. It's pretty amazing. And this is just visualizations, right? This is one of the things we can do here. You can go into, for example, signal processing, right? Albeit this might be less flashy because there is less drawings, but there will be some. So there is so much stuff in here, right? To play around with, to build things. Ryan, yeah, that's how we do it here. We stream. What do you mean you were asleep? You were not watching? Dude, come on. We keyed because we care. Don't worry, Chad, it's fine. So I would say ocaml is particularly well suited for a lot of computation, like low level sort of GPU style computation, right? Because of all the things that these two people have built. But most of what I've seen here, right, is very scientific oriented, right? I haven't found a quick and dumb, like something I could use, right? Way of like slapping together neural networks and being like, run neural network, go burr, right, on my GPU. So I think that there is room for putting layers on top of this. Yeah, he is the mod, isn't he? Yeah. What the fuck, man? What do I pay for? Anyways, the zoo system is also something super interesting for sharing scripts, right? You can do this. You create an owl script, and then you can just run this thing. And this was cool to think about in terms of how do we do something like live books. Take it out of my pay. I will. No, seriously, I'm happy that you slept well and then you're back here. Yeah, so just to round this up, right? There is so much to learn here in this space. This whole package is just massive, right? So someone needs to sit down and be like, okay, Chad, we're gonna build live book, right, for ocaml on top of this in a way that we can reuse these things. And I'm not talking about running ocaml on the browser. No, we need to be able to actually edit it in the browser and have it run on a server with a GPU. Boom. Yeah, we're doing just that. Look at this, Rand. Aren't you looking? It says deep neural network here. Natural language processing. I mean, come on. This is just absolutely fantastic. Seriously, I think that there is not a lot more, right? From here to, wow, ocaml is great at ML, right? I might be missing a lot of pieces, like, for example, having an OXSN, OXSN, this thing, Open Neural Network Exchange. And as a runtime, we might need to write some bindings for this, right? But if we're able to access that through OWL, right, and bake our own models and run them there, game over. We did it. And we probably want to do something like LangChain on top, right? Although I prefer Llama Index. Anyways, big rant. I need to do more work in this space. I do work in this space with Elixir, which is also kind of sucky, to be honest. But it's nice that we have NX in Elixir. which is a way of, I mean, this is way less flashy, right? But it's a way of actually writing Elixir code, like here, or I don't know where it is. Can't find it. You write Elixir and it compiles to GPU. Anyways, that's it. But yeah, we need to make it shippable. All right, folks. Sabine, are you on? Nully. Thanks for the follow, Nully. Yeah, not gonna lie, I've even played around with that. Numl, I think that will be the name of the package. Numerical ML. Sabine is live. Okay, folks. We're gonna go raid Sabine. Where the hell? Okay, we already were in a browser. No, this is not Sabine. Sorry. Tired hands. Oh, I might not see myself seeing myself. Anyways, so here we are. So how do? We open the chat and we do raid. Everybody get ready. Raid Sabine Ocaml. Boom. Let's fucking go.
I want to force myself to finish this one. So we made so much progress in the last 2 weeks. I really have to fix this bug so that I can stop thinking about this and forget about it, and that we finally see the correct library names on ocaml.org.
We did it.